Yeah, welcome back. So we are just continuing the previous lecture. In the previous lecture, what we were studying about? We were studying about matrices. So different kind of matrices we have seen. Then we studied about transpose of a matrix, and based on that we studied transpose of a matrix. Based on that, what kind of matrices we studied? Orthogonal matrix, then symmetric, and then skew symmetric. Right? These three kind of matrices we studied. Then we studied about transposed conjugate, or we call it tranjugate. What was tranjugate? A theta, right? Tranjugate. What is the meaning of that? That first you take the transpose, then you take the conjugate, or first you take the conjugate, then you take the transpose. Conjugate, transpose, or transpose, conjugate. Both are the same thing. So this is what we studied in the last lecture. So this is known as tranjugate. Okay. Now when we studied about transpose, then we studied about three different kind of matrices, right? Orthogonal, symmetric, skew symmetric. So here as well, based on tranjugate, there will be three kind of matrices. What will be that? Unitary, Hermitian, Skew-hermitian. Okay. Unitary matrix, unitary, Hermitian, and Skew-hermitian. So it will be easy for you to remember. Unitary is somewhat like orthogonal, Hermitian is somewhat like symmetric, and Skew-hermitian is somewhat like skew symmetric. Okay, so let's get started with the unitary matrix. So can you let me know what will be a unitary matrix? A square matrix A is said to be unitary matrix if A into A theta equals to I. What was orthogonal matrix? A into A transpose equals to I. So similarly, what will be your unitary matrix? A into A theta equals to I. Right, very simple thing. A is given, can you find out A theta? What is A theta? Take the transpose and then conjugate. So transpose of this will be 1 minus I divided by 2. Here, what is the meaning of transpose? That plus I will be replaced with minus I, or plus J will be replaced with minus J. It could be written as I as well, it could be written as J as well. Sometimes I will be writing it as J, sometimes I will be writing it as I. So both are the same thing. And along with that, we are taking the transpose as well. So that's why this element will come here, and then this element will go there. So this will become 1 minus I by 2, and this will become 1 plus I by 2. Okay, rest all remains same. Here plus sign, minus sign, plus sign, plus sign. So plus sign, minus sign, plus sign, plus sign. Only I will be replaced with minus I, and we have taken the transpose as well. Now you multiply both of them, what you will get? Do you know how to do the multiplication of complex number? If you don't know it, we will learn it. Okay, don't worry about it. But I expect that at least basics of complex number you can study from our network analysis playlist. In the last lecture also I told you that there is a playlist called network analysis on our YouTube channel, and in network analysis there will be first video basics of complex number, or you simply go to YouTube and type basics of complex number by PrepFusion Himanshu Agrawal. You will get a video and you can watch that particular video. So how to do the multiplication? So this element will be multiplied with this one, 1 plus I divided by 2, 1 minus I divided by 2. Then this element will be multiplied with this one, minus 1 plus I by 2, minus 1 minus I by 2. Right? So what I would do, 2 and 2 multiply 4, A plus B, A minus B, so A square minus B square. So what is I square? I square is minus 1. This will become 1 minus I square, right? A plus B into A minus B. So A square minus B square, 1 minus I square. What is I square? I square is minus 1. So this will become 1 plus 1. Here plus sign. Here what we can do? Again A plus B, A minus B. So A square minus B square. Look, A plus B, A minus B. So A square minus B square, right? So again minus 1 square is 1 only, and this is minus 1. So again 1 plus 1 divided by 4. So this will become 1 plus 1 divided by 4, which is 2 by 4, which is 1 by 2. So 1 by 2 plus 1 by 2 will be 1 only. So you do the multiplication, you are getting 1 here. In the next one, you will get 0. Okay. So in that manner, what you will be getting? 1, 0, 0, 1. That means it is an identity matrix. Understandable? Okay. So what this is known as, matrix A is known as unitary matrix. Okay. So let's do the important observation. Although we have already written the important observation for orthogonal matrix. So in orthogonal matrix, what was the condition? A square plus B square plus C square would be equals to 1. D square plus E square plus F square would be equals to 1. G square plus H square plus I square will be equals to 1. a square plus d square plus g square will be equals to 1, b square plus e square plus h square will be equals to 1, c square plus f square plus I square will be equals to 1. So similar condition will be here as well. It's just that this time mode will come. Why mode will come? Because this will be the complex number, no? 1 plus I by 2. What is the mode of this? I hope you know it. A square plus b square. So under root 1 square plus 1 square divided by 2. So that will be under root 2 divided by 2. That will be 1 by under root 2. So you need to take the magnitude of this. Magnitude of this. So in place of writing a square, I will write down mode of a square. So here mode of a square plus mode of b square plus mode of c square would be equals to 1. And similarly, it would go on for d square, e square, f square, g square, h square, I square. Let's go column wise now. A square plus d square plus g square, mode of b square plus e square plus mode of h square, mode of c square, mode of f square, and mode of I square. So this is the first condition. What was the other condition when it came to orthogonal matrix? What was the condition? A into d plus b into e plus c into f would be equals to 0. D into g plus e into h plus f into I would be equals to 0. A into g plus b into h plus c into I would be equals to 0. Similarly, column wise, a into b plus d into e plus g into h would be equals to 0. B into c plus e into f plus h into I would be equals to 0. And a into c plus d into f plus g into I would be equals to 0. This is the condition that we have seen in orthogonal matrix. Here what will be the condition? A into b bar. What is the meaning of b bar? Or write down conjugate. A into b conjugate. This could be a complex number, no? Here what is the value of b? Here what is the value of b? Minus I plus j divided by 2. Sorry, not minus I. Minus 1 plus j divided by 2. You call it j or you call it I, doesn't matter. So minus 1 plus I divided by 2. This is the value of b. So you multiply a with b conjugate. A with b conjugate. And if this is c and this is d, then multiply c with the d conjugate. What you will be getting? 0. Column wise multiplication I have done. As of now I am doing row wise. So let's just say this is a, b, c, d. So a into c conjugate plus b into d conjugate, that would also come out to be 0. It is just that the second number should be taken as conjugate. A into, okay, we are going column wise, okay. So a into b conjugate plus d into e conjugate plus g into h conjugate. Now do you know one thing? A plus b conjugate whole conjugate could be written as a conjugate plus b conjugate. Do you know this thing? This is how it could be written. This will come out to be 0. Similarly, other things as well. B into C conjugate plus E into F conjugate plus H into I conjugate. Similarly, A into C conjugate plus D into F conjugate plus G into I conjugate. Now here someone would have a doubt that sir, you are taking conjugate on the second element. Can I take the conjugate on first element? Basically someone would say that sir, can I write it down in this manner? A conjugate B plus D conjugate E plus G conjugate H would be equal to 0. And sir, here B conjugate C plus E conjugate F plus H conjugate I. A conjugate C plus D conjugate F plus G conjugate I. Yes, you can do it. What I am saying is that you can take the conjugate on the first element and second element as it is. So reversible it is. Why it is reversible? Because you see this particular thing. A conjugate A into B conjugate, D into E conjugate plus G into H conjugate, that is equals to 0. If I take conjugate on both of the side, what I will get? Just one second. Yeah. So what I was saying, A into B conjugate plus D into E conjugate plus G into H conjugate equals to 0. If I take conjugate on both of the side, what I am doing? I am taking conjugate on both of the side. So 0 is a real number. 0 conjugate will be 0 only. What about this one? This is alpha plus beta plus gamma conjugate, no? Alpha plus beta plus gamma conjugate, which could be written as AB conjugate plus DE conjugate plus GH conjugate and then whole conjugate. Now there is another property. If two numbers are there in multiplication and then you are taking the conjugate, then it could be written as A conjugate multiply with B conjugate. Okay, so A dot B conjugate conjugate, what I will get? Conjugate of A, B conjugate conjugate, conjugate and then another conjugate. What you will get? A conjugate, then again you take the conjugate. What is the meaning? That first you replace I with minus I and then minus I with plus I. So again you will get the same number, no? So this will be the same number only. Similarly here A conjugate B plus D conjugate E plus G conjugate H. So this could be written as this thing, which is same as this one. So basically the point is that you can take conjugate on any of the column. It is not necessary that sir first column will come as it is, then conjugate of the second. No, conjugate of first, second one as it is, multiplication, addition. Conjugate of this, second as it is, multiplication, addition. Conjugate of this one as it is, multiplication, addition. What you will get? 0. You can do it row wise as well. What do you mean by row wise, sir? A conjugate D plus B conjugate E plus C conjugate F, that would be equals to 0. Similarly D conjugate E plus E conjugate H plus F conjugate I, that would also be 0, and so on. You will be able to understand. A conjugate G plus B conjugate H plus C conjugate I, G conjugate A, H conjugate B, I conjugate C, right? So in that manner you can write down all these relations. So till this point they did not ask anything on a unitary matrix. Mostly what they focus on orthogonal matrix only, but who knows, in future they may ask. But yeah, these are not very important, so we are not going to solve any numerical, but you can remember the conclusion that if it is a unitary matrix, then mod of A plus mod of A square plus mod of B square plus mod of C square equals to 1, and similarly we'll go for all the rows and column, and multiplication addition taking conjugate of one of the row or column, addition of all of them would be equals to 0. So these conditions you can remember on your own. I hope it will be not very tough for you to remember. So if it is unitary, then all these conditions will be satisfied. Okay, although they don't ask much of the questions, but if they ask, then you will be able to solve it. Okay, simply you need to apply these conditions and you will be able to get the answer. Well and good. Let's go to the next one, Hermitian matrix. So what was the condition of symmetric matrix? Symmetric matrix, what was the condition? Sir, A transpose equals to A. So what do you think, what will be the condition of Hermitian matrix? A theta equals to A. Now you need to frame a Hermitian matrix on your own. Think about it. Let's just say A, B, C, D, okay, let's write down in this manner. Okay, D, E, F, G, H, I. What will be A theta? Transposed conjugate, right? You need to take the transpose as well, and then you need to take the conjugate as well. Transposed conjugate. So A conjugate, D conjugate, E conjugate. I am taking the transpose as well and taking the conjugate as well. G conjugate, B conjugate, and F conjugate. Then H, I, and C, right? A, D, E, G, B, F, H, I, C. Both are equal. If both are equal, then their corresponding element should be equal. That means A should be equals to A conjugate. Let's talk about the diagonal element only. B should be equals to B conjugate, and C should be equals to C conjugate, right? Can you let me know when this is possible? Can you let me know when this condition is possible? That some number is equals to its conjugate. What is the meaning of it? What is the conjugate of 2? Sir, there is no item. It is a real number. So what will be the conjugate of 2? 2 only. What is the conjugate of 2 plus I? That is 2 minus I. So they are not equal. But conjugate of 2 will be equals to 2 only. What will be the conjugate of 4? That will be equals to 4 only. What will be the conjugate of minus 2? That will also be minus 2 only. Because I will be replaced with minus I. No? Numbers will become same. Numbers will remain same only. What does that mean? That means A, B, C, which are diagonal element, they has to be real. Say yes or no. Very important conclusion. Not very important, but these kind of things can be asked in true or false. That which of the following statements are true? For a Hermitian matrix, the diagonal elements has to be real. Yes, they have to be real. Understandable? And rest you can think that D should be equals to G conjugate. D should be equals to G conjugate. So if I want to frame the Hermitian matrix, how would I frame? That I have put A, B, C, D, E, F, right? A, B, C, D, E, F. So if this element is E, if this element is D, then this should be D conjugate. Why is that so? Because D should be equals to G conjugate. D should be equals to G conjugate, or you can say, you can take conjugate on both of the side. If you take the conjugate of D, you will get D conjugate. If you take conjugate of G conjugate, you will get G. So G should be equals to D conjugate. G should be equals to D conjugate. So here E should be equals to this, sorry, H should be equals to E conjugate. Right? It is very simple, no? H should be equals to E conjugate. Take conjugate on both of the side. What you will get? E should be equals to H conjugate. If this is F, then this should be F conjugate. Did you? Okay, so this will be your Hermitian matrix. So from Hermitian matrix, only one question could be asked. What is that question? The question is that what is the what could be the nature of diagonal elements of a Hermitian matrix? They have to be real. You don't need to mug it up. You can simply derive it in the examination hall. You will be able to understand that, sir, yes, they have to be real. What about skew-hermitian matrix? What was your skew-symmetric matrix? Skew-symmetric matrix. It is pretty simple. Sir, it was A transpose equals to minus A. So I can write down A theta equals to minus A, or minus of A theta equals to A. Both are the same thing only, no? Here I can multiply with minus. So here also I will have to multiply with minus. So this will become minus A theta and this will become plus A. Both are the same thing. Again do the same thing. A, B, C, D, E, F, G, H, I. Right? You need to take A theta. So what that would be? A conjugate, D conjugate, E conjugate, then G conjugate, B conjugate, F conjugate, then H conjugate, I conjugate, and C conjugate, right? And then multiply with the negative sign here. Multiply with the negative sign here, because minus A theta should be equated to A, no? So multiply with the negative sign here, and both should be equal. So what do you understand? A should be equals to A conjugate. Sorry, A should be equals to minus A conjugate. B should be equals to minus B conjugate, and C should be equals to minus C conjugate. So first let's talk about the diagonal element. When it is possible. Let me know one thing. What is 2 conjugate? That is 2. What is minus 2 conjugate? So that is minus 2. Right? What is J conjugate? Or what is 2J conjugate? 2J conjugate. J should be J or I. Like, don't get confused between J and I. Okay, here I can write down 2I conjugate as well, where I is the imaginary. Okay, so 2I conjugate. What will be 2I conjugate? Minus 2I. If 2I was A, then what this is becoming? If 2I was A conjugate equals to minus A, B conjugate equals to minus B, or C conjugate equals to minus C. Basically, this minus sign can come here, no? A equals to minus A conjugate, so A conjugate should be equals to minus A. So minus sign can come here, this minus sign can come here, right? What you are getting? 2I conjugate equals to minus 2I. That means A conjugate equals to minus A. Similarly, if I would have taken this number, what will be the conjugate? 2 minus 3J. Both are complete different number. You cannot compare. But if it is purely imaginary, what this is known as purely imaginary, because there is no real part, no? This is the real part and this is the imaginary part. So if the number is purely imaginary, just like 2I or minus 2I as well, minus 2I conjugate, what will be minus 2I conjugate? I should be replaced with minus, I should be replaced with minus I. So minus minus will become plus. So if this was A, if this number was A, so A conjugate equals to, if this number was A, so what this is? This is minus A. A conjugate equals to minus A you are getting. So if it is purely imaginary, then what you will get? A conjugate equals to minus A. So what you will write down? The diagonal element of a skew-hermitian matrix has to be purely imaginary or 0. Why 0? What will be 0 conjugate? So that will be 0 only because it is a real number. Can I put minus sign in front of 0? Surely you can put. What will be 0 conjugate? That will be 0 only. In front of 0 you can put plus minus sign. So I am putting minus sign here. If this was A, 0 was A. So A conjugate is becoming minus sign and this is A only. So A conjugate equals to minus. So it could be 0 or purely imaginary. So the diagonal elements of a skew-hermitian matrix has to be purely imaginary or 0. Okay, this is also an important conclusion, or you would say this could be asked in 1 mark, that which of the following statements are true. For a skew-hermitian matrix, diagonal element has to be purely imaginary or 0. For a Hermitian matrix, diagonal element has to be real. Understandable? Very straightforward, very simple. Similarly, now you can frame your skew-hermitian matrix very easily. So these are purely imaginary number, no? So what I will write down, let it be ABC only, where I am saying ABC are purely imaginary or 0. Purely imaginary or 0. Okay, then you can see D is coming as minus G conjugate. So here G could be written as minus D conjugate. I hope you understand this. This will be minus E conjugate and this will be minus F conjugate. Understandable? Like basically what they are saying, D equals to minus G conjugate you are getting. So this minus sign can come here, G conjugate, and both side you can take the conjugate. So it will be minus D conjugate would be equals to G. So G is coming as minus D conjugate. Okay, so this will be your skew-hermitian matrix. So Hermitian matrix, what we studied? Unitary matrix we studied, A into A theta equals to I. Then we studied about Hermitian. Then we saw this condition, mod of A square plus mod of B square plus mod of C square equals to 1, and all these conditions we saw. Then we studied about Hermitian matrix, A theta equals to A. That means transjugate of A would be equals to A only. So transjugate you know how to take. So in the Hermitian matrix, what is the important condition we got? We got that diagonal element has to be real. In skew-hermitian matrix, what is the important condition we got? The diagonal element has to be either purely imaginary or 0. That's it. Okay. Now a random question I am asking you to solve. It is not related to Hermitian or skew-hermitian. Okay, it is a random question. The question related to Hermitian or skew-hermitian also we are going to solve here. But it is a random question. What is the question? That matrix A is given. Now new matrix B is defined as e to the power matrix A. You need to find out the summation of all the elements of matrix B. Basically, you need to find out the matrix B. What is our target? To find out the matrix B. So, sir, matrix B is given as e to the power matrix A. So, what do I do? I take the exponentials. This is what I do. That, sir, this will be, sir, here 0 is written. So, e to the power 0, e to the power 1, sir, e to the power 0 and e to the power 0. So, sir, what I am getting? What is e to the power 0? E to the power 0 is 1 only. And what is e to the power 1? E to the power 1 is e only. So, e to the power 0 is 1, 1, 1. This is answer you are getting absolutely wrong. Okay, it is wrong. Why is that so? When I asked you to do a square, did you do this thing? 0 square, 1 square, 0 square, 0 square. Did you do this thing? No. This was wrong. No, I told you a square means a into a. So a multiply with again a. You have to do the multiplication. Then whatever the answer you get, that will be the final answer. You cannot do like this element square, right? So similarly e to the power a. So can you do the element e to the power element a? No, right? So something we have to think. Do you remember this expansion e to the power x? It was 1 plus x square by 2 factorial, x cube by 3 factorial, x to the power 4 by 4 factorial, and so on. Similarly, e to the power matrix A is written. So let's keep 1 as it is. I don't know what will come at the place of 1, but this will be matrix A plus This will be matrix A square divided by 2 factorial. This will be matrix A cube divided by 3 factorial, and this will be matrix A to the power 4 divided by 4 factorial, and so on, right? So what you will write down in place of 1? These are the matrix, no? In place of x, this was a number, but here I am putting matrix. This was a number, here I am putting matrix. So in place of 1, what do you think what I should put? Identity matrix. Identity is showing 1 only, no? Like basically this shows 1. Okay, when you take its determinant, we will study about determinants. So you will get to know that determinant of identity matrix will be 1 only. So in place of 1, we will always replace identity matrix. Okay, always remember that. So basically our e to the power a would be 1 plus matrix, identity matrix plus matrix A plus matrix A square divided by 2 factorial plus matrix A cube divided by 3 factorial plus matrix matrix A to the power 4 divided by 4 factorial, and so on. This is something we need to solve. So identity matrix of order 2, this is of order 2 cross 2, no? So identity matrix of order 2 cross 2, I know that it will be, sir, 1 0 0 1, no doubt about it. Do I know matrix A? Yes, sir, it is already given. That is nothing but 0 1 0 0. Can I find out A square? What will be A square? 0 square plus 0 square 1 square 0 square 0 square? No. Matrix A square is matrix A multiply with A. What is matrix A? 0 1 0 0 multiply with 0 1 0 0. What you are getting? 0 multiply with 0 0, 1 multiply with 0 0, 0 multiply with 1 0, 1 multiply with 0 0, 0 with 0 0 with 0 0 0. So what you have seen? I was as it is, identity matrix, A was as it is. Then you got A square, which is coming out to be 0. Can you let me know what will be the value of A cube? Sir, A cube could be written as A into A square. A is some non-zero matrix. A is some non-zero matrix. If you multiply any matrix with 0, what answer you will get? Some random matrix is there, alpha, beta, gamma, neta. Multiply with 0 matrix. Alpha multiply with 0, beta multiply with 0 0. Alpha with 0, beta with 0 0, 0 0, 0. Everything is being multiplied with 0. So any matrix multiplied with 0 will be 0 only. Similarly, A to the power 4, A to the power 5. How I can write down A to the power 4? A to the power 4 could be written as A into A cube. So what is A cube? Again 0. So it will also be 0. So all the higher order matrix will be 0 only. A to the power 5 and so on. All the higher order matrix will be 0 0 0 only. So basically what really happened is that this came out to be 0. This also came out to be 0. This also came out to be 0. But only you are left with I plus A. That's it. Rest all higher order terms came out to be 0 only. A square 0, A cube 0, A to the power 4 0. So what did you see here? In our case, this is the answer we are getting. That's it. Now what is I? I is nothing but 1 0 0 1. And what is A? A is nothing but 0 1 0 0. Right? 0 1 0 0. So what is the addition we are getting? This is 1, this is 1, this is 0, and this is 1. There you go. So what is the addition of all the elements? What they are asking? Summation of all the elements. Summation of all the elements. Summation of all elements. What is that? 1 plus 1 plus 1 plus 0. That is equals to 3. That's it. This is the answer. Okay, this was the question. It was a good question. I just wanted to let you know the meaning of e to the power a. That's it. This was my target. Understandable? Okay. In the similar manner, they can ask you sin a, cos a, right? ln 1 plus a. So you should know their expansion and you will expand in the same manner. Is that clear to you? If someone asks you sin matrix A, in the angle matrix A is written. In the angle matrix A is written. So you write down the expansion of sin x, and in place of x you replace A. Understandable? So this is how we need to proceed. I hope it is clear to you. Okay. So exponential is actually famous. Exponential to the power A. This is very famous. So that's why I thought I should take it as a separate question, because next question you will be solving it. Okay. Which of the following statements are true for matrix A? that A is Skew-hermitian. What is the meaning of this if? IFF. What is the meaning of IFF? IFF means if and only if. If and only if. Now, sir, what is the meaning of this if and only if? I am writing something, okay? X if and only if y, or I would say X is true if and only if, or if of, I will simply write down the short form, which is if of, IFF. X is true if and only if y is true. What is the meaning of this? The meaning of this is, if X is true, then y is true. I don't know why handwriting is not coming good today. What is the meaning of this? If X is true, then y is true. And what is the meaning of and? And means both of the conditions should be satisfied. Not one condition, both conditions should be satisfied. If y is true, then X is true. This is the meaning of if and only if. Simple meaning of if and only if, that statement should go on both of the direction. In both of the directions, statement should be true. So how will I read it? First I will read A is Skew-hermitian matrix if and only if IA is Hermitian. But again, how will I read it? If A is Skew-hermitian, then IA is Hermitian. And if IA is Hermitian, then A is Skew-hermitian. So the statement should go on both of the direction, X to Y and Y to X as well. This is the meaning of if. Not only about mathematics, in any of the subject. In signal system as well, we have framed a lot of questions where the statement was written as if and only if. Even in the examination, these kind of statements have come. Okay, so you should know that if of is written, that means if and only if is written, then if X is true, then Y is true. If Y is true, then X is true. That's it. So both of the statement you need to take in action. Understandable? I hope it is clear to you. So let's solve option A. In option A, what we need to do? We need to proceed in two directions. What is the first statement? That if A is Hermitian, if A is Skew-hermitian, if A is Skew-hermitian, then IA is Hermitian. Okay, this is the first statement. Then and then opposite statement also we need to take. So if A is Skew-hermitian, what this is given. If A is Skew-hermitian, so what is given? Given that A is Skew-hermitian. This is given, right? So what about IA? So I will assume new matrix as B. This is the process. Sir, you need to prove, sir, it is Hermitian or not. That means you will have to take tranjugate. So I will take tranjugate on both of the side. Now do you remember how I will open it up? K A theta. What did I say? K conjugate A theta, right? So I will come outside, but as a conjugate, and A theta. What will be I conjugate? I conjugate is minus I. So minus A theta. Understandable? Is that clear to you? So this is B theta you are getting. Now what is A theta? A theta equals to minus A. A theta is equals to minus A, right? So what you are getting as B theta? Minus I as it is, and A theta is nothing but minus A. So what you are getting? IA. So eventually B theta is coming out to be IA, which was B only. So what you have seen as a conclusion, B theta is coming out to be B. What does that mean? B theta is coming out to be B, or you can say IA theta is coming out to be IA. That what does that mean? That IA is a Hermitian matrix. So this statement is true. But can I click on this option now? No. I have to check opposite as well, right? Opposite as well. That means if IA is Hermitian, then A is Skew-hermitian. So if IA is Hermitian, then A is Skew-hermitian. Okay, so what is given? That Ia is Hermitian. That means this matrix theta equals to, like, conjugate of this matrix is equals to this matrix only. This is given. Now conjugate of this matrix could be written as minus Ia theta, because I told you this property. Ia theta could be written as minus Ia theta. What property we have applied? Ka theta is equals to K conjugate A theta. Conjugate of K theta, sorry, conjugate of Ka is equals to K conjugate A conjugate. So similar property I have applied here. Directly this step we have seen, no? So this is the direct step I am writing now. That is given to minus A. I and I will get cancelled out. What you are getting? A equals to minus A theta, or you can say A theta equals to minus A. What you are getting? A theta equals to minus A. What does this show? This shows that A is Skew-hermitian. That means the statement is true in both of the direction. This statement is also true. So X is true, Y, then if X is true, then Y is true. If Y is true, then X is true. Statement is true in both of the direction, so option A is correct. Similarly, option B you can check on your own. We have done so many of calculation. We are studying matrices for last 4 hours. At least option B you should be able to check now. Okay. If A is Hermitian, then Ia is Skew-hermitian. If Ia is Skew-hermitian, then A is Hermitian. What you will do? A is Hermitian, write down the condition, then assume Ia as B. B theta you calculate. Then whatever the condition you get, based on that you will be able to see that option B is also correct. In both of the direction, option B on your own. Okay, what I am writing? Option B, homework on your own. Okay, let's check option C now. If A is Skew-hermitian, then e to the power A is unitary. What is given? A is a Skew-hermitian. Skew-hermitian. Then you need to comment on e to the power A. E to the power A we need to comment on. What is e to the power A? Sir, e to the power A is nothing but 1 plus A plus. Just as you see e to the power A, this is the process you need to do. In place of 1, what you will write down? I plus A plus so on. And so on. You need to comment on unitary. What was the meaning of unitary? If a matrix B is unitary, if B is unitary, then what you need to do? B theta into B. Here in unitary I missed something. B into B theta you write, A into A theta you write down, or you do A theta into A. Both are the same thing. Okay. So here as well, I write down B theta into B or B into B theta. Both are the same thing only. So B into B theta should be equals to I. This is our target, right? So can I calculate? This is my matrix B only, okay? E to the power A is nothing but I am assuming my matrix B. So this I already know, and I am assuming my matrix as B. E to the power A is nothing but B. So what I am calculating now? B theta, or I can write down E to the power A theta. Okay. Understandable? So what I am doing? I am simply taking theta here, nothing else. Is that clear to you? Like this expansion, and I am simply taking theta. So do you remember this thing? This property A plus B theta could be written as A theta B theta. This property we have written, no? Right? So if I am taking theta here, so it could be written as I theta plus A theta, A square theta. This is a constant number which will be 2 factorial. A to the power 3 theta, A to the power 4 theta, 4 factorial, and so on. Another property I am asking, A to the power n theta could be written as A theta to the power n. Can you prove it on your own? A to the power n, let's just say n is 3. So A into A to the power theta. Now I told you A into B into C to the power theta could be C theta B theta, A theta, right? This property we have seen. So A theta, from the last you need to write down A theta dot A theta dot A theta. So what this is becoming? A theta cube, and what this was? A cube theta. So A cube theta could be written as A theta cube. This was there, no? This property we saw. A transpose to the power n could be written as A to the power n transpose. So similar thing is there, right? I hope it is understandable to you. It is not very tough. So again another property here I am writing down. What property I am writing down? That A theta to the power n could be written as A to the power n theta. So here it is written A to the power 4 theta. So theta can come inside and 4 can go outside. So what we are getting? B theta as, what will be identity theta? Identity, what is identity matrix? Identity matrix is 1 0 0 1. You take its transpose, you will get the same matrix only, and you can take its conjugate as well. Why would you take the conjugate? All are real elements, no? So real elements will have the same conjugate only. So I theta will be equal to I only. I theta will be equal to I only. And what will be A theta? What is given? A theta is nothing but minus A. A theta is nothing but minus A, right? A theta is nothing but minus A. So A theta is nothing but minus A. Plus, this will become A theta square, right? This will become A theta square divided by 2. And what is A theta? A theta is nothing but minus A. So here what you will write down? This will be nothing but minus A. Plus, here what you will see? A cube theta square. So this could be written as, here it is A cube theta square. So this could be written as A theta cube, right? A theta cube, 3 factorial, right? Similarly, next could be written as A theta to the power 4 divided by 4 factorial, and so on. And you know one thing, that A theta is nothing but minus A. So here what I can replace? Minus A, minus A, minus A. I is I, this is A is replaced with minus A. Basically the scenario is that now A is replaced with minus A. Do you remember the expansion of e to the power A? Yes sir, it was I plus A square by 2 factorial plus A cube by 3 factorial plus A to the power 4 by 4 factorial. This was the scenario. But now A is replaced with minus A. So can you let me know what will be this is the expansion of what? This is the expansion of nothing but e to the power minus A. Do you understand this point or not? This was the expansion of e to the power A. I plus A square by 2. Then we find out B theta, which is e to the power A theta. Then I told you one thing. Then we do the expansion. Then I go to know one thing. What did I get to know? I theta plus A square theta plus this will be the expansion. And I go to know that this can come inside. So this will become, every A theta will become minus A. So isn't this particular expression we are getting, isn't it the expansion of e to the power minus A only? Because here in place of A, if I put minus sign, then A will be replaced with minus A, minus A, minus A, minus sign, minus A, and so on. So it is the expansion of e to the power minus A only. This is the expansion of e to the power minus A. So your B theta came out to be e to the power minus A. Or better I write down, what was my B? B was e to the power A theta. E to the power A theta. It came out to be e to the power minus A. So what is my B dot B theta now? That is e to the power A multiply with e to the power minus A. What that will become? A minus A. That would become e to the power 0. That would be identity matrix. Because every calculation we are doing in identity matrix. There you go. So what we are getting? B into B theta is coming out to be identity matrix only. What does that mean? B is unitary. B, which was e to the power A, is unitary. Okay. Important statement. Very good statement. If A is Skew-hermitian, then e to the power A is unitary. This you can do on your own. Option D you can do on your own. This will not be unitary. It will be nothing actually. Basically, let's do the option D. Option D. Do we have the page? Yes, we have the page. So A is Hermitian. given a theta equals to a, what we need to prove? We need to comment on this particular thing. So what we know, e to the power a theta actually came out to be basically e to the power a. What is e to the power a? It was I plus a square by 2 plus a cube by 3 factorial and so on. Now if I take theta here, so what will happen? A theta square, right? I hope you understand. Directly I have taken a theta inside. What I am doing is that this is the expression I am putting and I am taking e to the power a theta. So I theta will be I only, a theta. Then you know that sir, a square theta would come up, but you know that this theta can come inside and power 2. Why is that so? Because of this property. A to the power theta n could be written as a to the power n theta. So power and theta could be interchanged, divided by 2 factorial, a theta cube divided by 3 factorial. Now you know that a theta is nothing but a only. So this could be replaced as I plus a square by 2 factorial plus a cube by 3 factorial and so on. So what did you see here? That e to the power a theta is coming nothing but e to the power a only, right? So what do you see? E to the power a multiply with e to the power a theta is becoming e to the power a dot e to the power a, which will be a plus a e to the power 2a, which is not equals to identity matrix. That means, what does that mean? That means that e to the power a is not unitary. That means if a is Skew-hermitian, then only e to the power a is unitary. Otherwise, it is not. Understandable? So this kind of good question could be asked in the examination. A lot of people will struggle if these kind of questions are coming in the examination. Okay. So, like basically, you need to have a problem solving technique. That's it. And you need to know the meaning of if of as well. If and only if. What is the meaning of if and only if? Statement goes both of the direction. In both of the directions, statement would go. And after that, it is all mathematics. You just need to apply the mathematics and get the answer. Just write down the expression, then just apply all the properties, whatever the properties that you know, and based on that, you get the answer. Understandable? So these kind of questions also you can solve. Next, here our matrix is completed. Okay, our concept of matrix is completed. Again, the matrix will come into action, but after studying determinant. We will study determinant, and after that, both combined matrix and determinant we will study. So basics of matrix are completed. Before starting determinant, I want you to study a concept called concept of linearity. What is the meaning of linearity? Linearly independent matrix, linearly dependent matrix. This is the most important concept of this whole chapter. The whole chapter is based on this concept only, concept of linearity. What is the meaning of linearity? So, have you studied this kind of equation? Y equals to 2x plus 4. These kind of equation you might have studied. What was the graph of this kind of equation? Y equals to 2x plus 4. This kind of graph you will be getting with the positive slope cutting on positive y-axis. This kind of graph you will get, y equals to 2x plus 4. We used to call this as linear equation in two variables x and y. Linear equation in two variables x and y. What is the meaning of linearity? What is the meaning of linearity? Linearity means whatever the variable that you are having, that should have maximum power of 1. Here the power is 0. Here if I say 4 could be written as 4x to the power 0 or 4y to the power 0. What is y to the power 0? That would be 1 only. What is x to the power 0? That is also 1 only. So 4 into 1 will be 4. 4 into 1 will be 4 only. So maximum power of the variable should be 1. This is the meaning of linearity. Is that understandable to you or not? Along with that, there should be some relation between these variables as well. That y is equals to 2x plus 4. Okay. Although there is a difference actually, there is a difference between variable and the matrices. Basically, this is a linear equation, no? But this is not a linear system. This is a linear equation, but it is not a linear system. You will not be able to understand what I am saying. A linear system will have this value as 0. Basically, I give you some input, okay? Let's just say I give some input. and based on that you get some output. You applied as input as x, the output you are getting as x only, but here some multiplication factor is there. Let's just say 3 by 2 is there or 5 by 2 is there. Basically, you take the example of this mic. Okay, I am speaking slowly, but this mic is giving the output larger. That's it. I am speaking slowly, the mic is giving the output larger. So whatever the words that I am speaking, the same words are coming out, no? Whatever the words that I am speaking, the same words are coming out. It's just that they are larger. They are larger in magnitude. On mic, whatever that you speak, the same thing come out, no? Just the magnitude is a bit larger, right? But if I add a constant here, what is the meaning of adding a constant? You will not be able to understand because this subject is taken by a lot of students, not only electronic student. So this is known as DC phase shift. That means my signal is being shifted upward. You can just assume that whatever that I am saying, that will come out larger, but with some you cannot say delay. How will I make you understand? Basically, it has some DC value. What I mean to say is that when we talk about system, this value actually should be 0. When we talk about linearity in electronics, then this value should be equals to 0. But in mathematics, y equals to 2x plus 4 is also a linear equation. But when I talk about linear system, then my input and output should be related as y, then some constant factor x. Okay, here any constant factor can come. Although this is not a matter of concern, I just wanted to tell you the meaning of linearity. So there you go. This is the meaning of linearity, that maximum power of your variable should be 1. Maximum power should be 1. Y to the power 1, x to the power 1. Understandable? So this is the meaning of linearity. Now let's understand with respect to matrices. Matrix A is given, matrix B is given. Okay. Can you find out the relation between A and B? If someone looks closely, he can directly say that, sir, B is nothing but twice of A. Or someone would say that, sir, A is nothing but half of B. So I tell you one thing, that in your hand, I give you matrix A and I ask you that can you write down matrix B using the linear operation? Using any linear operation, I give you matrix A using any linear operation, can you find out matrix B? You will say, yes sir, I will simply double it, I will get the matrix B. In your hand, I give you matrix B. Listen to me very carefully. In your hand, I give you matrix B and I ask you, using linear operation, can you find out matrix A? You will say, yes sir. I will simply half it, I will simply get the half of it and I will get matrix A. So can I say comfortably that matrix B is depending on A or matrix A is depending on B or A and B are depending on each other? Again, I will repeat everything that I said. This was matrix A, this was matrix B. I wrote down matrix B equals to 2A, or I can write down matrix A as equals to B by 2. Now, I ask you one thing, that I give you matrix A in your hand. In your hand, matrix A is there. Now, I am asking you, using the matrix A, with the help of matrix A, can you write down matrix B? You will say, yes sir, I will simply double it. I will get matrix B. Then what do I say? I will give you matrix B in your hand. Using matrix B, can you write down matrix A? You will say, yes sir, I just need to get the half of it and I will get the matrix A. So comfortably I can say that matrix B is depending on A, or I can say matrix A is depending on B, or I can say A and B are depending on each other. Is that clear to you? Is this three statements clear to you? Matrix B is linearly depending. Okay, I may forget this word linearly, but in the whole chapter we are going to understand only the linear relation. So whenever I say A is depending on B, you always consider linear dependence I am talking about. Okay, so B is linearly depending on A is linearly depending on B, and A and B are linearly depending on each other. Understandable? One more statement will come here. Which statement will come? We will talk about it later on. Let's see another example. A and B matrix are there. Okay, this matrix A is there, matrix B is there. Can you write down matrix B in terms of matrix A? Someone will say that, sir, I will simply double it. Will you get it? Twice 2, twice 2, but 7 twice will be 14. It is 11. Like basically, can you write down B in terms of A only, multiply with some constant factor? Can you do this thing? What I mean to say is that you multiply A with the constant factor, which is alpha. So alpha, this will become 4 alpha, this will become 7 alpha. It should be equivalent to B, which is 2, 8, 11. Is it possible? From here it seems like that, sir, alpha value will be 2. Alpha value will be 2, sir. But here if I put alpha equals to 2, it should be 14, but it is 11. That means it is not even possible. So basically, I cannot write down this particular thing, that B is equals to alpha A. Neither I can write down A equals to some gamma B. Both are not possible. Basically, if I give you matrix A in your hand, what I am saying, I give you matrix A in your hand and I ask you that multiply your matrix A with some constant factor and get matrix B. What you will say? Sir, it is not possible. I give you matrix B in your hand and I ask you multiply matrix B with some constant factor and get matrix A. What you will say? Sir, it is not possible. Someone would say that, sir, I will add up 3 here. Basically, in B, what I will do? I will add up this matrix 0, 0, 3 and then, sir, I can get 2A. This is what I can get. In matrix B, I will add up 0, 0, 3. 0, 0, 3. 3 I add up, this will become 14 and then, sir, I will be able to get matrix A. This process you don't need to do, no. You cannot add up any constant value. I told you one thing, when it comes to system or when it comes to matrix, this constant factor should not be there. Okay, between y and x, yes, this constant factor could be there, but when it comes to matrix, this constant factor we will ignore. So this we cannot add up. Only with respect to matrix A only, you can multiply some constant value, you can multiply some imaginary value, but just you are having a matrix A. With the help of matrix A, write down matrix B. What you will say? Sir, not possible. With the help of matrix B, write down matrix A. What you will say? Sir, not possible. That means A is not linearly depending on B. A is not linearly depending on B. What will be the second statement? B is not linearly depending on A. Or you can say A and B are independent of each other. Here what did I say? A and B are linearly depending on each other. Here what I would say, A and B are independent of each other. Again, let me repeat the statement. I gave you matrix A and I asked you to write down matrix B in terms of A. What you said? Not possible. I gave you matrix B and I asked you to write down matrix A in terms of B. What you said? Sir, not possible. That means A is not depending on B or B is not depending on A or A and B are independent of each other. Like when we study the concept of eigenvalue, vector space, at that time you will realize that why these were very important. Okay, so I am focusing a lot on these statements. They are very, very, very important statement. A and B are independent of each other, or you can say A and B are two linearly independent matrices. Okay, two linearly independent matrices. Plural of matrix is matrices. Okay. Now let's see this example. 3 matrices are there. A, B, C. Okay. Now from here onwards, you need to understand every single line with a good amount of patience. You need to listen to my words very carefully. Okay. A, B, C is there. If you notice one thing, C is nothing but A plus twice of B. What did I do? I did the twice of B. What this will become? 4. This will become minus 2. This will become 2. This will become 4, minus 2 and 2. Here the elements were 1, 4, 7. You add both of them, what you are getting 5 here, what you are getting 2 here and what you are getting 9 here, which is matrix C only. Right? So in A, if you add up twice of B, what you are getting? Matrix C. Or what you can see that in matrix C, if I subtract twice of B, then I will get matrix C. In matrix C, if I subtract twice of this, 5 minus twice of this, what that would be? 4. 5 minus 4 will be 1. 2 minus twice of this, what that would be? Minus 2. So 2 minus of minus 2 will be 4. 9 minus of 2 will be equals to 7. And from this equation also you can see, no? If I put A here, sorry, if I put 2B here, what this will become? C minus 2B. So what is A? A is nothing but C minus 2B. And what is B? B is nothing but C by 2 minus A by 2. Or you can say 0.5 into C, 0.5 into C minus 0.5 into A. Right? Just do the half of it. What you will get? 2.5, 1 and 4.5. And subtract half of it. What is half of it? this will be 0.5, this will be 0.2, sorry, this will be 2 only, and this will be 3.5. So 2.5 minus 0.5 will be 2. 1 minus 2 will be minus 1. 4.5 minus 3.5 will be 1. So this is how you can get matrix B. So these are the relations we are getting as C, A and B. So can I say C is linearly depending on A and B? What I am saying, C is linearly depending on A and B. A and B, not A or B. What I am saying, C is linearly depending on A and B, or A is linearly depending on C and B, or B is linearly depending on C and A. Three statement, very carefully you are able to understand. C is linearly depending on A and B, A is linearly depending on C and B, and B is linearly depending on C and A. Now in your hand, I give you matrix A only. In your hand, I am giving you matrix A, and now I am asking you, with the help of matrix A, write down the rest of the matrix. With the help of matrix A, write down rest of the matrix. What you will say? Only with respect to the help of A, write down rest of the matrix. You will say, sir, not possible. In your hand, I am giving you matrix B, and I am saying, with the help of B, write down rest of the matrix. What is the meaning of rest of the matrix? Then that means with the help of B, you need to write down matrix A as well, and you need to write down matrix C as well. So can you write down matrix A with the help of B only? That what I am saying is that you have matrix B, multiply this with the constant factor and get matrix A. Is that possible? Multiply this with the constant factor, this will become 2 alpha, this will become minus 1 alpha, and this will become alpha. That should be equivalent to 1, 4 and 7. From here alpha value is minus 4, from here alpha value is 7, from here alpha value is 1 by 2. That means it is not possible. So what I am saying is that with the help of only B, you cannot write down matrix A, or with the help of only B, you cannot write down matrix C, or with the help of only A, you cannot write down matrix B. With the help of only A, you cannot write down matrix C. With the help of only C, you cannot write down matrix A, or with the help of only C, you cannot write down matrix B. But now in your hand, I give you matrix A and B, and then I ask you, with the help of A and B, can you write down C? So in your hand, how many matrices are there? 2 matrices are there. In your hand, how many matrices are there? 2 matrices are there. So in your hand, you are having matrix A as well, and you are having matrix B as well. So with the help of A and B, can I write down C? Yes. What will be the value of alpha? Alpha value will be 1, beta value will be 2. Similarly, in your hand, if I give you B and C, can you write down A? Yes. What will be the value of alpha? I am giving you B and C. So alpha value will be minus 2, C value will and beta value will be 1. And in your hand, I give you B and C, can you write down A? Sorry. In your hand, I am giving you C and A. C and A, can you write down B? Yes, sir. What you will say? Sir, C I will multiply with 0.5 and A I will multiply with 0.5, and then I will subtract both of them. I will get matrix B. That means C is linearly depending on A and B. A is linearly depending on C and B, and B is linearly depending on C and A. There is one word. What is that word? Independent matrix. Number of independent matrix. Number of independent matrix. So in this scenario, how many number of independent matrices are there? The answer will be 2. Whatever the number of matrix you need in your hand to write down rest of the matrix, these are known as independent matrix. In your hand, how many matrices do you need to write down rest of the matrix? What will be your answer? Sir, I need at least 2 matrices. Sir, you give me A and B, I can write down C. Sir, you give me B and C, I can write down A. Sir, you give me A and C, I can write down B. So how many matrices do you require in your hand? You will say, sir, I require 2 matrices. Using 2 matrices, I can write down next matrix. So there are total 2 independent matrix and 1 dependent matrix. C is depending on A and B, or B is depending on A and C, or A is depending on B and C. Is that clear to you or not? people will study completely linear algebra and they will never able to understand the meaning of these statements. Although we will tell you technique, we will study about rank, we will study about nullity, and you will be able to solve these kind of problems. But you need to know the meaning as well. What is the meaning? Meaning means how many matrices you need in your hand to write down the rest of the matrices. That is known as number of independent vectors. Okay, we will use the term vector. These row matrices or column matrices will become vectors. Later on, I will introduce the meaning of vector, and then I will tell you that vector could be written in terms of matrices as well. So there we will use the term number of independent vectors. Here we are using number of independent matrices. So here number of independent matrices are 2 and number of dependent matrices are 1. Someone would say that, sir, C is also depending, A is also dependent, and B is also depending. So, sir, number of dependent matrices are 3. No, number of dependent matrices are not 3. These are the condition of OR, right? That either you write down C in terms of A and B, or you write down A in terms of C and B, or you write down B in terms of C and A, right? So, if there are 2 independent matrices, then 1 is dependent matrix. So, these are the statements that has been written here. C is linearly depending on A and B is linearly depending on A and C, and A is linearly depending on A and B. And the statement is there are 2 linearly independent matrices, or let's keep it matrix, 2 independent matrix and 1 dependent matrix. Now this is your task. Let me know how many number of independent matrices are there and how many number of dependent matrices are there. Don't mess it up. It's up to you. You need to write down. I hope you will be able to get the correct answer. How many number of independent matrices are there and how many number of dependent matrices are there, you need to tell that. Although all these concepts will become very easy when we study the concept of nullity. So there you will just find out the nullity and you will be able to tell how many number of independent matrices are there. Okay, and rest of the matrices will be linearly dependent. So very easily you will be able to tell. But that will come when we study the method. But here I am not telling you the method. Here I am telling you the meaning. So you need to tell them. You need to tell me the number of linearly dependent matrices and linearly independent matrices. Along with that, you need to write down these statement as well. Okay. In your hand, I give you matrix A, and I ask you, can you write down matrix B and C? You will say yes, sir. With the help of matrix A, sir, I can write down matrix B as well, and I can write down matrix C as well. What you will say? That, sir, if I just do the half of matrix A, I will get matrix B. And sir, if I just multiply 3 by 2 to matrix A, I will get the matrix C. 3 by 2 you multiply, 9 by 2 will be 4.5 and this will be minus 1.5. So this is the scenario. Or someone would say that, sir, you give me matrix B, if I do the twice, I will get matrix A. And sir, if I do the thrice, I will get matrix C. Someone will say that, sir, you give me matrix C only, and if I do the 2 by 3 times, I will get matrix B, and if I do the 1 by 3 times, sorry, if I do the 2 by 3 times, I will get matrix A, and if I do the 1 by 3 times, I will get matrix B. In your hand, how many matrices you require? Only one. You give me A, sir. With the help of A, I can write down B and C. Sir, you give me B only, sir. With the help of B, I can write down A and C. Sir, you give me C. With the help of C, I can write down A and B. So let me know how many linearly dependent matrices are there and how many linearly independent matrices are there. So number of linearly independent matrices. How many matrices are there? Only one. Independent. Independent means whatever that is in your hand. That this guy is independent of everyone. This guy doesn't depend on anyone. That A will come that yes, I am alone with my help. I am alone enough to write down B and C. Or what B will say, that I am alone enough to write down A and C. What C will say, that I am alone enough to write down A and B. So I am independent of everyone. I don't depend on anyone. So number of independent matrices are only one. But number of dependent matrices, if A is in your hand, then what B will say? B will say that I am depending on A. If A is in your hand, what C will say? C will say that I am depending on A. So if one matrix is linearly independent, then two are dependent. If A is independent, if A is independent, then B and C are depending on him. Here what was the scenario? If these two are independent, then C was depending on them. So here one dependent and two linearly independent. One dependent and two linearly independent. But here one is independent and number of linearly dependent are 2. Is that clear? All these statement, as of now you are feeling that sir this is very simple statement, why you are spending so much of time. But when we study vectors, vector span and all this kind of topic, you will say sir they were very simple but we are messing up the problems. Okay, so you need to understand the meaning as well. So what I am saying, A is linearly depending on A and A is linearly depending on, okay, not and. So these 6 statements I can write down. A is linearly depending on B, A is linearly depending on C, B is linearly depending on A, B is linearly depending on C. So these 6 kind of statement I can write down. But what about the number of dependent and independent vector? There is only one linearly independent vector and 2 linearly dependent vectors are there. So did you understand the meaning of linear relation, vector, or as of now we did not introduce the vector. So okay, here I have written vector, but as of now you don't know what is a vector. So you will understand it as a matrix only. Okay, there is only one linearly independent matrix and 2 linearly independent matrices. Okay, so matrix word you can replace with vector. Okay, as of now this is matrix only. Okay, as of now this is matrices. Understandable? So you understood the meaning of linearity as well, and you understood the meaning of linearly independent and dependent matrices as well. Understandable? And linear relation also you understood. What is the linear relation? This is the linear relation. Can you write down a linear relation? A linear relation between PQR, PQ and R. Can you write down a linear relation between PQ and R? Yes sir, it would be P equals to 2Q plus 3R, or I can simply write down P equals to alpha Q plus beta R, or what I can write down, Q equals to alpha beta I am using here, so gamma P plus neta R, or what I can write down, R equals to AP plus BQ. So this is known as the linear relation between PQ and R. Understandable? So here we have understood the meaning of matrices as well, and we have understood the meaning of linearity as well. Next, what we need to get started with? We need to get started with determinants. So I will take a break, drink some water, and then I will come back. We will start studying about determinants. Very important topic, and a lot of guys would know the basics, but surely there will be something new terms, something new you will be learning, which will be helpful for you for your GATE examination. Okay. So yes, if you already know it, then you can watch it in a quicker manner. But again, there will be some new things which might be helpful for your GATE examination, so you can understand those things. So I will take a break and then I will come back. You can also drink some water. You can revise whatever that we have studied, and then we will come back and start studying about determinants. All these things will again come up, but I will not be explaining the meaning. Okay, when we study about rank and nullity, at that time all these things will again come up, but there I will only tell the method, not the actual meaning. Okay, so there I will just simply tell the method, I will write down the equations, and then this is how you need to solve. So here I have spent a lot of time. I hope it is understandable to you guys. Okay, yeah, so we will come back and start studying about determinants. Yeah, welcome back. So let's study about determinants. So basics of matrix have been completed, and one concept of linearity also we have seen. So let's get started with the determinant. So what is a determinant? So determinant you always find for a square matrix. Okay, from now onwards our matter of concern will always be square matrix. So you find the determinant only for square matrices. What is a determinant? Determinant is a fixed value, fixed numerical value. Let's just say this is a matrix A, and I ask you to find out a determinant of A. This is a matrix A, right? This is a matrix A, and I am asking you to find out its determinant. So what I will write down, what is the notation? Notation would be determinant of A, or you make the mod sign. Okay, this is written as mode of A, it doesn't mean that it will be only a positive value. What is the meaning of mode of minus 3? That means 3 only. It is just the notation. It doesn't mean that it will be only a positive value. It could be negative as well. It is only the notation that this is how I will, this is the notation I will give. And this matrix sign, matrix was closed in this bracket, right? Now it will be closed in two vertical lines. Two vertical lines I will make, A, C, B, D. So this is the notation. This is how I will denote the determinant. Now what will be the value of determinant? For a 2 cross 2 matrix, the value of determinant will be this element multiplied with this element, A multiplied with D minus this element multiplied with this element. So this will give you a fixed numerical value. Let's take an example. This is a matrix A I am having. This is a 2 cross 2 matrix A I am having. Let's just say this element is 2, this element is 1, this element is minus 1, this element is minus 3. You need to find out the determinant of A. So what you will do? You will write down in this manner 2 minus 3 minus 1 1. This is the notation. And what you will do? 2 multiply with 1 minus 1 multiply with minus 3. What you are getting? 2 minus 3. So what will be the determinant? Determinant will be minus 1. So if this is the matrix A, then its determinant is coming out to be minus 1, which is a fixed numerical value. So sir, you told me how to find the determinant of a 2 cross 2 matrix. Sir, what about 3 cross 3 matrix? What about 4 cross 4 matrix? What about 5 cross 5 matrix? So we will learn that method, but you need to have some patience. After studying some concept, we will understand the meaning of finding the determinant of a 3 cross 3 matrix, 4 cross 4 matrix, 5 cross 5 matrix. But as of now, you just need to remember that how to find out the determinant of a 2 cross 2 matrix. A multiply with D minus B multiply with C. 2 multiply with 1 minus 1 multiply with minus 3. Answer I am getting as minus 1. Understandable? So it will be a fixed numerical value. It will be a single fixed numerical value. No matter whether the matrix is 2 cross 2, 3 cross 3, 4 cross 4, it will be a fixed numerical value. So this was your matrix and determinant will be a fixed numerical value. Understandable? Let's understand the concept of minors. What we need to find out? We need to find out the minor. What do you mean by minor, sir? So this is a matrix A. How will you represent determinant of A? Sir, the same matrix, sir. The only change I need to bring is this bracket will be replaced with the vertical lines. That's it. So sir, when I solve it, I will get a numerical value which I don't know as of now. I don't know how to solve this particular determinant. As of now, I don't know the numerical value. Sir, what do you mean by minor? So minor are found with respect to a particular element. The question could be find out the minor of A11, find out the minor of A22, find out the minor of A33, find out the minor of A13, find out the minor of A21. So how will you find out the minor? So what they are asking you to find out the minor of A11. So I will represent that with M11. Now what I will do? With respect to A11, whatever the row and columns are there, I will block those rows and columns. With respect to A11, I will block the rows and columns. With respect to A11, I will block the first row and first column. So what I am left with? I am left with these 4 elements. With respect to A11, I have blocked this row and this column. So what I am left with? I am left with A22, A23. I will write down in the same manner, left to right. In the left side, what is written? A22, A32 is written. And here A23, A33 is written. And then I will calculate its determinant. Okay, what I will calculate? I will calculate its determinant. There you go. This will be my minor of A11. That's it. So what will be its determinant? I know that A22 multiply with A33 minus A32 multiply with A23. A23 multiply with A32. There you go. That's it. This is the minor of A11. You block the row corresponding to A11. You block the column corresponding to A11. Then whatever that you are left with, simply calculate the determinant. Write down in the same manner. Left one would be written left one. Upper one would be written upper one. This line was upper, so here also it is upper. This line was lower, so this line is also lower here. Understandable? So this is what we will do. Similarly, can you write down the minor of A13? What will be the representation? M13. Can you write down the minor of A13? Yes sir, this is my A13. With respect to A13, I will block the row and the column. So what I will be left with? I will be left with A21, A22, A31 and A32. So this is my 2 cross 2 determinant I am getting. find out the value of this 2 cross 2 determinant. What that would be? A21 A32 minus A31 A22. There you go. Remove this one. Similarly, I need to find out the minor of A22. What that would be? M22. Determinant it would be A22. Where is A22? This is A22. So with respect to A22, this is the row and this is the column. What I am left with? A11, A13, A31, A33. A11, A13, A11, A13, A31, A33. Okay, it is very simple, right? A31, A33. So what you will be getting? A11, A33 minus A13, A31. What about A32? That will be M32. With respect to M32, I will block the row and column. A32, A32, A32. So what I will be left with? A11, A23, A11, A23, A11, A23, A1 with respect to A32. So A11, A23, A21, A13, A21, A13, A21, A13. So this will be the answer. A11, A23 minus A21, A13. So this is the concept of minor. Solve this numerical on your own. You need to find out the minor of element 3. Where is element 3? This is the element 3. So with respect to this, you block this particular scenario and you will get the minor of element 3. So minor of element 3 will be this and this will be blocked. So what you will be left with? 2, 5 minus 3 minus 2. 2, 5 minus 3 minus 2. 2, 5 minus 3 minus 2. So 2 multiply with minus 2, then minus sign, then 5 multiply with minus 3. So what you are getting? Minus 4 plus 15. What you will get? 11. Okay. Then you need to find out the minor of element 0. Minor of element 0. Again it will be a matrix, right? So with respect to 0, block row and column. What you will be left with? Minus 1, minus 2, 1 and minus 3. So minus 1, 1, minus 3, minus 2. Minus 1, 1, minus 3, minus 2, right? Minus 1, 1, minus 3, minus 2. So what you are getting? Minus 1 into minus 2. Then minus sign, 1 into minus 3. So what value this will be? 2 plus 3. That would be 5. Then next you need to find out minor of element 2. What that would be? Minor of element 2. 1, 3 minus 2 minus 4. 1, 3 minus 2 minus 4. 1, 3 minus 2 minus 4. Sorry, 1, 3 minus 2, 4. You need to find out for element 2. 1, 3 minus 2, 4. That would be 4 minus, so 4 into 1. This will be 1 into 4 minus 3 into minus 2. So 4 minus 6, that would be 10. Okay. So answer is 10. So this is how you can find out the minor. So minor is also a certain value. Element 3, 11. For element 0, it is 5. For element 2, it is 10. So this is how we find out the minor. So concept of minor is clear to you. Now there is a concept called cofactor. What is the concept? Concept of cofactor. So cofactor is nothing but minor only. Cofactor is equals to minor only, but when I plus j is even. And cofactor equals to minus of minor if I plus j is odd. So let me tell you the meaning. What you need to find out? You need to find out the cofactor of a11. So cofactor of a11 I am representing by f11. Okay. Cofactor of a11 I am representing by f11. So in my mind cofactor will not go. In my mind only minor will go. Okay. How can I find out the minor of a11? Sir, minor of a11 will be nothing but, sir, I will block this row and column. I will be left with a22 multiply with a33 minus, or simply write down the matrix first. A22, A23, A32, A33. So what I will be getting? A22, A33 minus A23, A32. This is the answer I will be getting. Then I will see what is the value of I plus j here. 1 plus 1. 1 plus 1 is 2. So cofactor equals to minor only. Plus sign only. Basically, no change in the sign. Cofactor will be equals to minor only if I plus j is even. But if I find out the cofactor of A12, what I need to find out? Cofactor of A12. So cofactor will not go in my mind. In my mind, what will go? I will find out the minor of A12. What will be the minor of A12? In my mind, minor is going on. Okay. I need to find out the minor. So that would be A21, A23, A31, A33. A21, A23, A31, A33. So what is the answer I will get, sir? A21, A33 minus A31, A23. Then I will do I plus j. What is the value I am getting? I plus j. 1 plus 2. I plus j. What is the value I am getting? 1 plus 2. What is the value? 3. What is this number? This number is odd. If this number is odd, so I will put the negative sign here. So negative of this will be my cofactor. So when you calculate the minor, you don't care about positive negative sign. When I was calculating the minor, I was not caring about positive negative sign. But when I calculate the cofactor, so cofactor is nothing but minor only, but I need to care about 1, 2, which is 1 plus 2, which will be 3. Since it is odd number, I will put up the negative sign here. What about A31? So cofactor of A31 will be same as minor of A31 only. Why is that so? Because 1 plus 3 is 4, which is an even number. Cofactor of A32 will be equals to minor of A32 but with the negative sign. Why is that so? Because 3 plus 2 is 5, which is an odd number. So here what will be the answer? For F31. 3, 1. So this is what you will be blocking. So you will be left with A12, A13, A12, A13, A22, A23. This is what you will be left with, right? So this will be your answer. A12, A23 minus A22, A13. And what about this? What about cofactor of A32? So it will be equals to minor of A32 only, but with the negative sign. Why negative sign? Because when you do 3 plus 2, what you are getting? You are getting an odd number. So 3, 2. 3, 2. So A11, A23, A11, A23, A21, A13. A21 here, A21 here, A13 here. Right? So what you are getting? Minus sign outside. A11, A23 minus A21, A13. There you go. This is the answer we are getting. Okay. So this is the concept of cofactor. So cofactor you have understood, minor you have understood. Now we need to find out the determinant of a matrix order having 3 cross 3. So this was our matrix. Our matrix was this one only. This was our matrix only. This was our matrix A, and we are finding the determinant of this matrix. What we are doing? We are finding the determinant of this matrix A. So when we are finding the determinant of this matrix A, this is how I can represent it. Now how will I find out the determinant? So there are multiple ways of finding the determinant. So what I am writing down? Finding determinant with respect to. So first I am finding the determinant with respect to row 1. Basically this is row 1, this is row 2, this is row 3, and this is column 1, column 2, column 3. So for a 3 cross 3 matrix, you have 6 ways to find out the determinant. You can find out the determinant with respect to row 1, or with respect to row 2, or with respect to row 3, or with respect to column 1, or with respect to column 2, or with respect to column 3. So what we are doing? We are finding out the determinant with respect to row 1. Okay. So determinant of A will be represented by this sign. Vertical lines in between A is written. So what I will do? With respect to row 1, what is the first element of row 1? Which is A11. A11 multiplied with the cofactor of A11 plus A12 multiplied with cofactor of A12 plus A13 multiplied with cofactor of A13. That's it. This will be the determinant value. So let's write down what answer I will be getting. A11 multiply with cofactor of A11. Will that be equal to the minor of A11? Because 1 plus 1 is 2, which is an even number. So same sign I will be getting. here what I am writing now, A12 cofactor of A12 will be equals to the minor of A12 but with the negative sign. Why is that so? Because 1 plus 2 is odd, plus A13 M13, because 1 plus 3 is 4, so cofactor and minor both are same. Now A11, what will be M11? Block these two, what you will be getting, A22 A23 A32 A33. So after solving it, what I will be getting, A22 A33 minus A32 A23. Is that clear to you? Say yes or no, right? This I will block, this matrix, this determinant I will get, which is A22 multiply with A33 and A32 multiply with A23. Then there is a negative sign, then I will write down A12 as it is. Now minor of M12, so this and this I will block. What I will be left with, A21 multiply with A33, A21 multiply with A33 minus A31 multiply with A23, A31 multiply with A23 plus A13 M13. So what you will be getting, A13 M13. So this and this will be blocked. So A21 A32, A21 A32 minus A31 A22. This is the answer you will be getting. You can solve it. Okay. When we solve it, what is the answer we are getting? Determinant of A we are getting as this, A11 can be multiplied inside. So A11 A22 A33, A11 A22 A33 minus A11 A23 A32, A11 A23 A32. Then another minus sign, A12 A21 A33, A12 A21 A12 A21 A33 plus, because minus minus will become plus. So A12 A31 A23, A12 A31 A23 plus A13 A21 A32, A13 A21 A32, then minus A13 A31 A22, 13 A31 A22. There you go. This is the answer you are getting. Okay, I hope it is, calculation is all fine. A11 A33 A32 A23, then 122133, 122133, then 123123, 123123, then 132132, 132132, then 133122, 133122, 112233, 112332, 112233, 113323. Yes. Now similar thing you can do with respect to row 2 as well. With respect to row 2 as well. Now I am finding out the determinant with respect to row 2. So what will be the determinant of A with respect to row 2? So what is the first element of row 2? That is A21. So A21 multiply with the cofactor of A21 plus A22 multiply with the cofactor of A22. Basically A21 A22 A23 plus A23 multiply with the cofactor of 23. Now let me know one thing. A21 cofactor of 21 will be equals to the minor of 21 only, but with the negative sign. Why is that so? Because 2 plus 1 is odd, plus A22 cofactor of 22 will be equals to the minor of 22 only, and there will not be any negative sign. Why is that so? Because 2 plus 2 is even. Then A23 multiply with the minor of 23. It will be same but with the negative sign. Why negative sign? Because 2 plus 3 is 5, which is odd. Is that clear to you? So this is the answer we will be getting. Now what will be the answer we will get? Minus A21. Now what will be M21? M21. This and this will be blocked. M21. This and this will be blocked. And what you will be left with? A12 multiply with A33. A12 multiply with A33 minus A32 multiply with A13. A32 multiply with A13 plus A22. A11 multiply with A13. This and this will be blocked. A11 multiply with A13 minus A31 multiply with A13. A31 multiply with A13 minus A23. So M23 you need to find out. M23 you need to find out. This and this will be blocked. So A11 A32, A11 A32 minus A31 A12, A31 A12. If you solve it, you will get the same answer only. Let's check it. So with the negative sign, we are getting A21 211233. 211233 with the negative sign. With the positive sign, we are getting 213213. 213213. 213213. 213213. Then here with the positive sign, we are getting 221133. 221133. Then here with the negative sign, we are getting 223113. With the negative sign, we are getting 223113. There you go. Then with the negative sign, we are getting 231132. With the negative sign, we are getting 231132. There you go, this value. And with the positive sign, we are getting 231231. 231231. There you go. So isn't it same? This value and this value both are same only. This is what I told you, that with respect to any row, with respect to any column, you can find out the determinant. So this we found out with respect to row 2. Similarly, we can find out with respect to row 3 as well. Similarly, we can find out with respect to row 3 as well, which you will do on your own. Okay. And then we can find out with respect to column 1 as well, with respect to column 2 as well, with respect to column 3 as well. So I will show you with respect to column 1. Okay. Rest you will do on your own. So let's find out with respect to column 1. So column 1. So what is the first element? That is A11. So A11 multiplied with cofactor of 11 plus A21 multiplied with cofactor of A21 plus A31 multiplied with cofactor of A31. Right? A31 multiplied with cofactor of A31. That will be equals to A11. Minor will be same because 1 plus 1 is 2, which is the even number. 2 plus 1 odd number. So minor will be having the negative coefficient, that will be equals to the cofactor, and 3 plus 1 is 4, which is a odd number. Sorry, which is a even number. So even number, that means A31 M31. So plus minus plus. So can we solve it? A11, what will be M11? M11 we already know, A22 A33 minus A32 A23. A32 A23 minus A21. What is M21? What is M21? M21. So this and this will be blocked. You will be left with A12 A33. A12 A33 minus A32 A13. A32 A13 plus A31. What will be M31? A12 A23 minus A22 A13. A22 A13. And you can also check that this value will be same as this value only. 112233 112233 113223 113223 122133 122133. Then with the positive sign 213213 213213 311223 311223, and with the negative sign 312213, with the negative sign 312213. There you go. So this determinant is same as this equation 1, 2 and 3 all are same. Similarly, you can find out with respect to C2 as well and with respect to C3 as well. You will get the same answer. Is that clear to you? So this is how we find out the determinant of a 3 cross 3 matrix. Same goes for 4 cross 4 matrix as well. Right? Again A11 F11 plus A12 F12 plus A13 F13 plus A14 F14. In that manner, you can find out the determinant for a 4 cross 4 matrix as well. Same goes for 5 cross 5. Same goes for 6 cross 6 as well. Understandable? So let's solve a question. You need to find out the determinant of A. So with respect to any row, you can find out. Let's find out with respect to row 1. Okay, what I will do? Determinant of A. So with the time, I need to build up the practice. This is 2, I need to block them. Then 3 into 4. 3 into 4, which will be 12. Minus 2 into 1. Then there is a negative sign. Why negative sign would come up? Look, in my mind, what I will do is that I will make a matrix like this. Plus, minus, plus, minus, plus, minus, plus, minus, plus. In the alternate order. Why I am making this matrix? This is A11, right? This element is A11. If you calculate the cofactor with respect to A11, then cofactor will be equals to minor. This is your A12. What will be your cofactor? M12, 1 plus 2 is odd, negative sign. So positive, then negative sign. Then again here, F13, that will be equals to M13 only, because 1 plus 3 will be 4, which is a even number. What about this number? This is A22. That will also be equals to F22, sorry, for A22, F22 would be equals to M22 only. Why is that so? Because 2 plus 2. So here positive. What about this one? Let's take anything random. So this is A32. So F32. 3 plus 2 is odd, so negative sign. So this is first row, first column, positive sign. First row, second column, sorry, yes, first row, second column, negative sign. First row, third column, positive sign. Second row, first column, A21, 2 plus 1, 3, negative sign, positive, negative. So no matter with respect to whatever that I am expanding, I am going with respect to row 1. So what I will pick up? Plus, minus, plus. So then negative sign would come up. Then what is the number? Minus 1 is written. Now I will block this and this. What I will be left with? 4 into 1 minus 1 into minus 1, that will be plus 1 here. Understandable what I am doing? What I was supposed to do, this I did. I was supposed to put a plus sign here, right? Then minus sign. Now I am supposed to put the cofactor. What will be the cofactor? Cofactor will be 1 into 4 minus 1 into 1. This is not the cofactor, this is the minor. But it is the second element, first row, second element. That's why the cofactor will come with a negative sign. So already a negative sign I am putting up here. I am doing minus sign here. And then I am just simply writing down this value, which is 4. This will become minus 1. So minus minus, this will become plus. Okay, you need to build up this practice. Then again, what you know? Plus 0. Right? Next value will be coming with plus. So plus 0. So this and this you need to block. So 2 into 1 minus 1 into 3. So minus 1 into 3 will be minus 3. So minus minus will become plus here. This is the answer I am getting. So 0 into anything will be 0 only. I don't need to care about it. So 2 into minus 10. This will be plus 1 and this is 5. So what is the answer? Minus 20 plus 5. That will be minus 50. Let's do it with respect to column 2. Okay, with respect to column 2. So what I will be starting with, sir, plus minus. So this will be minus plus minus. So first of all, when I am writing down minus 1, what is the first element? Minus 1, but another minus sign will come up, right? Because minus plus minus. So first I will write down the element minus 1, then another minus sign would come up, and then I will write down the minor. What will be the minor? 4 minus of minus 1. So 4 minus of minus 1, that will become plus. The next element plus 3 I will write down. And with respect to 3, 4 into 2, 8. 8 minus 1 into 0, that will be 0 only. So minus 0. Then next I will write down minus plus minus, again minus 2. Minus and then 2. So this and this will be blocked. 2 into 1 will be 2 only. And 1 into 0 will be 0. This and this are blocked. So 2 into 1 will be 1. 1 into 0 will be 0. So what we are getting? This is 1, this is 5. Plus 24 minus 4. Calculation mistake. Five, okay. Then 3, 8, okay. 24. Then minus 2, minus 4. There is no calculation mistake here. Answer is 25 only. So there is a calculation mistake here. So 12 minus 2, 10. Okay. Why this negative sign here? This is plus 20, no? Okay. This is positive sign only. 12 minus 2 is 10. So 20, 25. Answer is 25. Why minus 15? Answer is 25 only. Understandable? So with respect to anything you can do. But what I would prefer? I would prefer it doing with R1 only. Why is that so? Because in R1, one of the element is 0, no? So with respect to 0, I will write down 0 here. Do I need to do this calculation? I don't even need to care about 0, no? So with the row or column where maximum zeros are present, I will do my expansion with respect to that row and column only. Because if number of zeros are more, then I will reduce the expansion. Is that understandable to you? Like I can do the expansion with respect to column 3 as well. Why is that so? Column 3 will be easy for me. Why is that so? Because in column 3 I will start with 0. Now here I will write down 0. Now whatever that comes I don't need to care about it. No, here whatever comes I don't need to care about it. Then I can simply go to column 2. So here plus minus sign would come up. Then minus 1 is written. Then I can find out the minor. This and this will be blocked. So 2 into 2 4, minus 1 into minus 1 will be 1 only. Then plus minus plus. So this and this will be blocked. So 6 minus 1 7. 6 minus of minus 1. So this will become plus. There you go. What you are getting? This is minus 3 plus 28. So that will be 25. This is the answer. Okay, so here with respect to 0, whatever the value is coming, I don't need to care about it, because 0 multiplied with anything will be 0 only, right? So always I will do my expansion with respect to the row or column where maximum zeros are present. Let's just say this question is coming. So how will you do the expansion of it? With respect to which row or column you will do the expansion? Will you do like this? With respect to row 1, then every calculation you need to do. Here also every calculation you need to do. Here also 2 calculations you will have to do. Here also 2 calculations you will have to do. But if you look here, with respect to column 2, if I do, what will happen? 3 into 3 or minus 3, plus minus plus minus plus minus, you can make plus minus plus minus plus minus plus minus plus. Okay, so first one is minus, so minus 3, then block this one. 7 into 4 28, 3 into 2 6, 28 minus 6, then plus 0, whatever comes I don't care about it, then minus 0, whatever comes I don't care about it. That's it. This is the answer. So what is the answer you are getting? Minus 66. This is the answer. You can do with anything else as well. Like let's do it with respect to row 3. So 2 will come, plus minus plus, so 2 will come here, and this will be blocked. So 3 into 3 9, minus 0 into anything, that would be 0 only. Then minus would come, 0 anything comes I don't care. Then plus would come 4, 17 into 0 will be 0, 7 into 3 will be 21. So 0 minus 21. So 18 minus 84. So again minus 66. Okay, so that's the answer. Understandable? So this is how we do the calculation. This is how we calculate the determinant of A, which is minus 66. I hope it is understandable to you. And a lot of people already know all these kind of things. But again, yeah, even if you don't know it, then also we are learning here. This question was asked in GATE 2026 EC. Okay, GATE 2026 EC. You need to solve it on your own. Which of the following statements are true if a determinant of M is 0? Determinant of M is 0. What will be the determinant of M? 2 1 1 1 3 0. Sorry, determinant of M is not equals to 0, right? Determinant of M is not equals to 0. This should not be equals to 0. So first let's calculate what is the determinant of M. So what do you think? How will you expand? You can expand it with respect to row 2 as well or column 3 as well, right? Understandable? Because one of the term will be gone, no? So plus minus plus, plus minus, I am doing it with respect to column 3, column 1, column 2, column 3. So this will be plus, then minus, then plus. So plus and then downward minus and then plus. Basically in the alternate order, you can take any order, plus minus plus, plus minus plus, plus minus plus, minus plus minus, right? Plus minus plus. So any alternate order you can take. So with respect to column 3, I can write down plus minus plus. So 1 will be coming as positive. So this and this will be gone. A minus of minus 3. Then 0 would come. I don't care about it. Then plus B would come. So this and this will be gone. So 3 into 2, 6. Minus 1 into 1 will be 1. So 6 minus 1 will be 5. So what you are getting? A plus 3 plus 5B. Okay, so what they are saying? Determinant of M should not be equals to 0. That means A plus 3 plus 5B should not be equals to 0. This is the condition. Now let's check the options. In option A, if I put A equals to minus 1 by 2 plus 3 as it is, and I put B equals to minus 1 by 2 as well. So what I am getting? This will be 3 minus 1 by 2, that will be 2.5, and 5 into minus 1 by 2, that will also be 2.5. What you are getting? You are actually getting it 0. But you need the option where it should not be equals to 0. That means this will not be true. Then option B you can check. In place of A you will put 1 by 2 plus 3. Here you will put 1 by 2. So here you are getting 2.5 and 3.5. 2.5 plus 3.5, which is actually 6, which is not equals to 0. Right? So this option is correct. Similarly, you can check option C as well. Minus 3 plus 3, A is minus 3 plus 3, B is 0. So what you are getting? Minus 3 plus 3 will be 0 only. Yes. So this is coming out to be 0, but we needed not equals to 0. So this is also wrong. And last option, option D, we can check. A is 1 by 2 plus 3 plus 5 into minus 3. So what answer I will be getting? 3.5 minus 15, whatever the value you get, it will surely not be equals to 0. That means yes, this option is also correct. So option D is also correct. So B and D are correct. Understandable? So this is how we solve the questions of a determinant. Understandable? Now we will see the properties of determinant, but after a break. Okay, I will have my breakfast now, and then I will come back and we will see the properties of determinants. Well and good. So you can do it on your own. This is matrix A I have written. Can you find out the value of a determinant of A? Okay. Matrix A I have written. Can you find out the value of determinant of A? Then find out the value of determinant of B as well. Then find out A plus B, and then find out the value of a determinant of A plus B. Then find out A into B. Then find out the determinant of AB. And with respect to that, you will be able to see this. Okay. Well and good. So you can do this on your own, and 1 and 2 will be verified. Along with that, you will let me know what will be the value of a determinant of a identity matrix. Any identity matrix you take. 1, 0, 0, 1. What will be the value? 1 into 1 minus 1 minus 0, that would be equals to 1. Or you take this one. 1, 0, 0, 0, 1, 0, 0, 0, 1. With respect to any row, you can expand, or with respect to any column, you can expand. I am expanding with respect to this one. So what I will be getting? 1 into 1 will be 1, 1 minus 0. Then minus 0, whatever comes, I don't care about it. Then plus 0, whatever comes, I don't care about it. What is 1 into 1? That will be 1 only. So determinant of any identity matrix is 1. So this property we have proved here only, which is our next property, that determinant of any identity matrix is 1 only. And these two properties also you can prove on your own. You can find out the value of determinant of A, determinant of B. You will get to know that determinant of A plus B is not equal to determinant of A plus B, but determinant of AB is equal to determinant of A dot determinant of B. Okay. So this also you can prove on your own. Right. So I will take a break and then I will come back. Yeah, welcome back. So did you try this one? Mode of A. Did you find out mode of A? What was mode of A? Minus 1, minus 6, right? Mode of A would be 1 into minus 1 will be minus 1. Then 3 into 2 will be 6. So minus 1 minus 6, it would be minus 7. And what was mode of B? So 3 minus of minus 1, it would be 4. So 1 into 3 will be 3. Minus 1 into minus 1 will be minus 1. So it will become 4. Now what is A plus B? A plus B is 1 plus 1 is 2. 2 minus 1 is 1. 3 plus 1 is 4. And minus 1 plus 3 is 2. Right? Now you need to find out determinant of A plus B. So what will be determinant of A plus B? So determinant of A plus B is coming out to be 4 minus 4. It is actually coming out to be 0 only. And what is AB? A into B. So 1 into 1, 2 into 1, 3. 1 into minus 1, 3 into 2, 6. 3 into 1, minus 1. So 2. Minus 3 and minus 3, minus 6. There you go. Okay. So what you will get? What is your determinant of AB? So minus 18 minus 10, that would be minus 28. So what do you see here? Your determinant of A plus B is coming out to be 0. Determinant of A plus B is coming out to be 0, which is surely not equals to determinant of A plus determinant of B. Because what is your determinant of A plus determinant of B? That is 4 minus 7, that is minus 3. And what is determinant of A multiplied with determinant of B? That is minus 28. So here if you see, determinant of AB is coming out to be determinant of A multiplied with determinant of B. So that's it. This is what you can remember. So it will apply for everything, like determinant of A plus determinant of B plus determinant of C will not be equals to determinant of A plus determinant of B plus determinant of C plus determinant of D. ये क्या हो रहा है यार, टेढ़ा क्यों लिखा जा रहा है? But determinant of A, B, C, D would be equals to determinant of A multiply with determinant of B multiply with determinant of C multiply with determinant of D. Is that clear to you? Okay. Then what was the determinant of identity matrix? That was equals to 1. This we have already seen. Now there is another question for you. This is your matrix A. Find out the determinant of A. What is that? 4 into 2, 8 minus 3, 5. This is your matrix B. Find out the determinant of matrix B. What is that? 24 minus 9, 15. For matrix C, what do you see? 24 minus 9, 15. 24 minus 9, 15. And for matrix C, 24 minus 9, 15. Understandable? When we move from matrix A to matrix B, what is the changes? What is the change you can see? You can see that the row 1 of matrix A, is multiplied with 3. This is the change you can see. Row 1 of matrix A is multiplied with 3. Nothing happened with row 2. Row 2 is as it is. Only change is there in row 1. Row 1 is multiplied with 3. Understandable? And what really happened with the determinant value? That is also multiplied with 3. When you move from A to C, what do you see? When I move from A to C, row 1 is as it is, but row 2 is multiplied with 3. Row 2 is replaced with thrice of this. Row 2 is multiplied with 3. So 3, 12. And row 1 is as it is. Again, what really happened? This became 3 times. When you move from matrix A to D, what do you see? A to D. Column 1 is multiplied with 3. Column 1 is multiplied with 3. Column 2 remains as it is. And when I move from A to E, what do I see? When I move from A to E, what do I see? Column 2 is multiplied with 3. Column 2 is multiplied with 3. Column 1 remains as it is. Here also what really happened? In both of the cases, determinant value is multiplied with 3. So when your determinant is being multiplied with the constant factor, when your determinant was multiplied with 3, here the determinant was 5. From 5 to it became 5 into 3. What does that mean? That means one of the row was multiplied with 3. One of the row was multiplied with 3. When it became from 5 to 5 into 3, then what really happened? One of the row was multiplied with 3, or one of the column was multiplied with 3, or one of the other column, which was C2, that was multiplied with 3. So when your determinant value is being multiplied with some constant value, that means that particular value will be multiplied in one of the row or in the column. Is that understandable to you or not? So previously my determinant was 5. Now it became 5 into 3. That means the value 3 was multiplied either in this row or in this row, or let's understand from here, either in this row or in this row, or in this column or in this column, in this column or in this column, or in this row or in this row, and rest all the things remains as it is. So what I mean to say is that if this is my determinant of A, can you write down k dot A determinant? K dot A determinant. So this will be a fixed value, no? Let's just say this value is alpha. So we are writing k dot alpha. So this fixed value multiplied with the value of k. So how I can write down this particular determinant? So this is how I can write down the determinant. What I will do is that, sir, I will simply let's take it here, because again and again I will have to copy, no? Sir, what I will do is that I will simply take it up, I will put it here. I can either multiply the complete row, complete first row, or sir, what I can do, I can multiply the complete second row. Or sir, what I can do? I can multiply the complete third row, sir. Or sir, what I can do? I can multiply the complete first column. Let me copy it again and again. What I can do? Sir, I can multiply k with first column. Or sir, I can multiply k with second column. Or sir, I can multiply k with third column. So this k going inside will be getting into either one of the rows or one of the columns. And if I need to take this k outside, then directly it will come outside. Basically, if I talk about the matrix, okay, if I talk about the matrix 2, 4, 6 and 8, 10, 12. So from matrix, how will I take the common value outside? The common is 2. So this is how I will take it outside. 1, 2, 3 and this is 4, 5, 6. So 2 multiply with this matrix, that means in matrix this value will be multiplied with every element. But when it comes to determinant, let's just say this value is written alpha, beta, gamma, neta, and I need to multiply a constant value too. So it will be multiplied with one of the rows or one of the column. Is that understandable to you? Or if this is the scenario, if this is the scenario that the values are written in this manner 2 alpha, 2 beta, 2 gamma, 2 neta. So let me know what value can come outside. Is it correct that this was the scenario and if I replace it somewhat like this, is this correct or not? You guys will let me know. That's a 2 you take outside, alpha, beta, gamma, neta. Is this correct? No, this is wrong. Why is that so? Because I told you this constant value come from one of the rows. So 2 came out from the first row. From the first row 2 came out. From the first row 2 came out, but it did not come out from second row. If you take it out from second row, then another 2 would come. Then another 2 would come out. So first only 1 2 came out, then another 2 would come out. If this 2 also needs to come out, so 2 into 2 will be 4 here. This will be 4 into this matrix. Is that understandable to you? So constant value will come out, but from one of the rows or from one of the columns. Is that clear to you or not? I hope it is understandable. One of the rows, one of the rows, one of the rows or one of the column. And when you multiply that constant value, then it will go inside to one of the rows or to one of the columns. Is that clear? Very important property. Okay. Now this is the question for you. Use your brain. Let me know the relation between determinant of B and determinant of A. I want you to find out the relation between these two guys. What will be the relation? What will be the value of this alpha? Without solving this matrix. Can you do it? Let's do it with the with simple concept. So this is matrix A is given. Can I find out the determinant of A? Yes, I can do it very easily. So this is 1 into 1. This will become 3. Then this minus will become plus. So this will become 2. So determinant of A is coming out to be 5. Can I find out matrix B? Yes, sir. Very easily you can find out matrix B as well. How will I find out matrix B? Matrix B is nothing but minus 2A. So in case of matrix, what really happens? In case of matrix, what happens is that every element is multiplied with 2. This is, I am talking about matrix. This is the relation. Matrix B is nothing but minus 2A. You can write down in this manner as well, or you can write down 2 into A in this manner as well. Both are same. So when it comes to matrix, every element will be multiplied. Every element will be multiplied with 2, multiplied with minus 2. So this will become minus 2, this will become plus 2, this will become 0. This will become minus 4, this will become minus 2, this will become plus 2, multiply with minus sign, no? And this will become 0 only, this will become minus 4 and this will become minus 2. Minus 4, minus 2, 2, minus 2, minus 4, minus 2, 2, 0. Yeah, this is the scenario. Now can you find out the determinant of B? Yes sir, I can find out the determinant of B. What that would be? Minus 2 into 4 minus 8, 4 minus of 8, then minus 2 into 8. So what answer I am getting? Minus 24 minus 16. What is the answer? Minus 40. Is that clear to you? Okay, this is the answer we are getting. So here answer we are getting 5, here answer we are getting is minus 40. Okay, now let's think about it. B equals to minus 2a, this was given. I am taking determinant on both of the side. Just think about it. When it was matrix and I multiply with minus 2, then each row was multiplied with minus 2, no? Each row was multiplied with minus 2, or you can say each column was multiplied with minus 2. Now when it comes to determinant, I need to take out this minus 2. Is that clear to you? What I mean to say is that when I calculated determinant of B, this is what I was doing. That this is minus 2, 2, 0, minus 4, minus 2, 2, 0, minus 4, minus 2. Right? So now what I can do, from first row I can take out minus 2. From first row I am taking out minus 2. From second row as well I am taking out minus 2. And from third row as well I am taking out minus 2. From each of these rows I am taking out minus 2, minus 2 and minus 2. Is that clear to you or not? Okay. From each row I am taking out minus 2, minus 2 and minus 2. So what I will be left with? I will be left with, this will be 1, this will be minus 1, this will be 0. This will be minus 2, sorry, minus 2 I am taking out, no? So this will be 2, this will be minus 1, and minus 2 I am taking out. This will be 2, this will be 1 and this will be minus 1. And this will be 0, this will be 2 and this will be 1. So what this value will become? This value will become minus 8. And what is this? This is nothing but determinant of A. And this is your determinant of B. There you go. This is the answer you are getting. Is that clear? So when it is about matrix, you are multiplying minus 2, then in each row it will be multiplied. Row 1, row 2, row 3. But when you take it out, when it comes to determinant, then from each row it will come out again and again. So minus 2 into minus 2 into minus 2. So if I write down a property that let A is a square matrix of order n cross n, and the determinant of A is given by this sign. Now I frame a new matrix, matrix B, which is K into matrix A. So what will be the determinant of B? So determinant of B I can write down K into A. Now if I want to take out this K, then how this K will come out? In this manner? No, this K will come out with K to the power n. Why is that so? Because when this K was multiplied to matrix, this is the multiplication with matrix. When this K was multiplied to the matrix, then it was multiplied to each element. But when it came out in case of determinant, then it came out from each row. Minus 2 from here, minus 2 from here, minus 2 from here. So K from first, there will be how many columns? Sorry, there will be how many rows? N rows will be there. Right? So it will come out from one row, then from second row, then from third row, then from fourth row, then fifth row, and then sixth row. So total K to the power n. And determinant sign I should have made here, not the matrix sign. Is that clear to you? When we multiply with the matrix, the K will go inside to each element. But when we talk about the determinant, the K will come outside of each row. So row 1, row 2, row 3, row 4, row 5, row 6. So from each row it will come out. Is that clear to you or not? I hope it is understandable. Okay, very important property. If you don't understand this property, or if you don't remember this property, then there will be a lot of things to worry about, because it will be used at a lot of places. Okay, so K to the power n E. Is that clear to you? All good? All fine? Now 3 matrices are given. You need to find out their determinant. So this property is completed. Property 4 is completed. Okay, so we solved some questions, and with respect to the question, we understood the property. So here basically there are two kind of properties. One was that if I multiply with a constant value, that goes inside to one of the rows only. Okay, and if your complete matrix is multiplied with some constant value, then when we calculate the determinant, it will come out as a constant value to the power n. Constant value to the power n. Okay. Now next property. This is the next property. Can you let me know if this was a matrix? Although it is a determinant, if this was a matrix, then it would have been a diagonal matrix. If this was a matrix, then it would have been a upper triangular matrix. If this was a matrix, then it would have been a lower triangular matrix. Forget about it. Now you calculate the determinant value. What will be the determinant value? Sir, here I can do the expansion with respect to first row. So 2 into minus 1 into 3, that will be minus 3. So what is the answer I am getting? That is, I am getting is minus 6. Or I can write down this as 2 into minus 1 into 3. What will be the determinant value be here? Sir, if I need to do the expansion, I will do the expansion with respect to first column. Right? I will do the expansion with respect to first column. So in first column, what will happen? 2 here. This and this will get cancelled out. So minus 2 into 3. Minus 2 into 3. And then 0 into 1 will be 0. So what you will get? 2 into minus 2 into 3. This is what you are getting. So what you are getting? 2 into minus 2 into 3. And for for this matrix as well, what you will do? You will do the expansion with respect to first row. Here with respect to first column. Here with respect to first row. So let's do the expansion with respect to first row. So what you will be getting? Sir, 1 as it is. Minus 2 multiply with 1. 1 multiply with 0. That would be 0 only. So minus 2 multiply with 1. And then everything is 0, 0, 0. I don't need to care about it. Here also 0, 0, no need to care. 0, 0, no need to care. So eventually what you are getting? 1 into minus 2 into 1. So what is the determinant value you guys are getting? What do you think? So determinant value is nothing but the multiplication of the diagonal elements. 2 into minus 1 into 3. 2 into minus 2 into 3. 1 into minus 2 into 1. So for diagonal matrix, for upper triangular matrix, or for lower triangular matrix, the value of determinant is equals to their diagonal elements multiplication. Okay, so this has been written. For a diagonal upper triangular and lower triangular matrices, the value of determinant is equal to the multiplication of their diagonal elements. Very simple and very straightforward. Okay. This question has been framed that there is a matrix B which is 4 into I3. What is I3? I3 is the identity matrix of 3 cross 3 order. You need to find out the determinant of B. So what is I3? This is your I3. 1 0 0 0 1 0 0 0 1. This is I3. And what is B? B is nothing but 4 I3. So 4 0 0 0 4 0 and 0 0 4. What kind of matrix it is? Diagonal matrix. So just multiply 4 into 4 into 4. That will become 4 to the power 3. That will be 64. Or what I can do? Matrix B is 4 I3. What you need to do? You need to calculate that determinant. So 4 I3. Okay. Now this 4 needs to come out. How it will come out? 4 to the power n. What is the order? 3. 4 to the power 3. I3. What is 4 to the power 3? 64. And what is the determinant of I3? Determinant of any identity matrix. What is that? 1 only. So what is the answer? 64. So all these calculations we don't need to do. Simply determinant of B will be equal to determinant of 4 into I3. Now if 4 comes out, it will come out as 4 to the power 3. 4 to the power 3 is 64. Then determinant of I3 will be 1. So answer is 64 only. That's it. There you go. Understandable? Very straightforward. Now determinant of A transpose is equals to determinant of A only. You can do it on your own. Okay, very simple, very straightforward. Determinant of A transpose is equals to determinant of A. It is pretty simple, no? Because you are just doing the transpose. It will not change the determinant value. Take any matrix, okay? Any random matrix you take, 3, 4, 4, 2. What will be the determinant value? 4 minus 12. What will be the answer? Minus 10. Now you take the transpose. 2, 3, 4, 2. What will be the determinant value? 2 into 2, 4. 4 into 3, minus 12 only. This is minus 8 and this is also minus 8. Okay, so you can verify that determinant of A transpose is nothing but determinant of A only. Now what about this? Determinant of A to the power n. What is the meaning of A to the power n? Determinant sign as it is. What is the meaning of A to the power n? A to the power n means A multiplied n times. A multiplied n times. Right? Now do you remember this property? Determinant of A multiply with determinant of B multiply with determinant of C multiply with determinant of D. So determinant of So determinant of A into A into A into A could be written as determinant of A multiply with determinant of A n times. So it could be written determinant of A to the power n. Say yes or no. So what we have seen, A transpose to the power n, or we can say A to the power n transpose could be written as A transpose to the power n, right? Then we saw A to the power n transucate could be written as A transucate to the power n, and then we saw determinant of A to the power n could be written as determinant of A to the power n. Is that clear to you or not? Okay, let's just say there is a matrix A is given, so the determinant of a matrix A is 2. Now we are defining another matrix A to the power 4. What will be its determinant? So you will simply do 2 to the power 4, that will be sir 16. Understandable? Okay. So these three properties we have seen. Find out the determinant of these matrices. What will be the determinant? Sir, I will calculate the determinant with respect to row 1 here. So sir, 0 multiply with something, minus 0 multiply with something, plus 0 multiply with something, 0 multiply with something, 0 multiply with this, 0 multiply with something else. Whatever that is being multiplied, do I care about it? No, because this row is 0, no? So 0 multiply with something, 0, 0 multiply with something, 0, 0 multiply with something will be 0. So 0 plus 0 plus 0 will be 0. Here I will do the expansion with respect to first column. 0, 0, 0, 0 multiply with something 0, 0 multiply with something 0, 0 multiply with something 0, answer will be 0. Here I will do the expansion with respect to second column. 0 multiply with something plus 0 multiply with something plus 0 multiply with something will be 0. Here what will be the answer? Is there any row which is completely 0? Is there any column which is completely 0? No. So you will see the maximum number of zeros. Here number of zeros are 2, here also number of zeros are 2, and here also number of zeros are 2, here also number of zeros are 2. So you can do the expansion with respect to anything. I am doing the expansion with respect to column 1. So plus minus plus, this will be plus. So 0 into 3 will be 0, minus 2 into 1 will be 2. So what will be the answer? Minus 2 will be the answer. So here answer is not 0. So one complete row or one complete column is 0. Here complete column is 0. Here complete column is 0. Here complete row is 0. So in a matrix, if your complete column or row is 0, then the value of a determinant will also be 0. If any row or column, in bracket I am writing or column means the same property will go for column as well. So if any row or column of a matrix is completely 0, then the determinant of A will be 0 only. Okay, any of the complete row, any of the complete column is 0, then it will be 0 only, which is pretty much understandable as well. Very straightforward. Why it is understandable? Because sir, I will do the expansion with respect to that row only, that column only. You can do the expansion here as well, you will get the same answer. You can do the expansion with respect to third column as well, you will get the same answer. Okay, always you will get the answer to be 0 only. Understandable? Right? Now solve this question. Find out the determinant of A, find out the determinant of C, find out the determinant of B. Okay, so what is the determinant of A? You are getting 1 into 3 minus 2, that would be 1. Then minus 2 is there, so here minus 3 you will get. So answer will be 7. 7 answer you are getting. Okay, you can do it on your own. 7 answer you will get. Here what will be the answer you will be getting? I will do that expansion with respect to column 1, because 1 of the 0 I will get, no? So plus minus, so minus 1, and then 6, then minus 1, and then 3, minus 2. So here answer you will get minus 7, and you can do this one as well. Here also you will get answer minus 7 only, right? Yes, answer minus 7 only. How I am able to write down the answer directly? If you see from matrix A to matrix B, matrix A to matrix B, how we have went here? Minus 1, 1, 2, 1, 2, 0. If you look closely, then row 2 and row 3 are interchanged. Row 2 has gone to row 3, sorry, not row 2 and row 3, row 1 and row 2. Sorry guys, row 3 is as it is, no? Row 3 is as it is. Row 3 is as it is. But row 1 is interchanged to row 2. And how you went from A to C? If you look closely, column 2 is interchanged with column 3. 211, 211 has come here and this 023 has come here. But column 1 is there as it is. So column 2 has been interchanged to column 3. So in a matrix, what I am saying, matrix or determinant, whatever you want to say, if two columns are interchanged or two rows are interchanged, then the determinant value is multiplied with -1. And it is pretty understandable as well, because this was plus minus plus and then minus plus minus then plus minus plus. So plus minus plus sign has been interchanged to minus plus minus sign. Or you can say if there is interchange between these two, then also there is a change of negative sign, right? Or if there are interchange between these two guys as well, then also there is a change of a negative sign. Basically, if I interchange row 1 and row 3, what if this was the scenario? That row 2 is as it is, -1, 1, 2. But row 1 and row 3 are interchanged. So 0, 1, 3 goes here and 1, 2, 0 goes here. Then also the answer will come out to be -7. Or what I could have done? That let's take this example. That 0, 2, 3 comes here. In between 2, 1, 1 remains as it is, and this 1, -1, 0 comes here. What will be the answer? Again -7 only. Okay, because these two are interchanged. But what if I do in this manner? What if I do in this manner? What do I do? That this 2, 1, 1 comes here. Okay, this 0, 2, 3 comes here, and thus this 1, -1, 0 comes here. Can you let me know what will be the answer? Think about it. Without doing the calculation, can you let me know what will be the answer? This 0, 2, 3 has come here. Okay, 2, 1, 1 has gone here, and this has come here. What will be the answer? 7 again. Why is that so? Because what would have happened? First, they would have interchanged the place. First, this would be as it is. Okay, but 0, 2, 3 would have come here, and 2, 1, 1 would have come here. So what will be the answer here? -7. Why so? Because these two guys interchange. Now what will happen? This 0, 2, 3 will remain as it is. These two guys will interchange now. So 1, -1, 0 will go to the end, and this will come in the beginning. 2, 1, 1. So from -7 to what will be the answer now? +7. Again one more negative sign. Are you able to understand this point? So at the end of the day, what you need to remember, if two rows or column are interchanged, if two rows or column, the same property will go with the columns as well. Whatever the property that we are learning with respect to row, the same property would go for columns as well. If two rows or column are interchanged, then the determinant value will be multiplied with -1. If any two rows or two columns of a determinant are interchanged, then the value of determinant will be multiplied with -1. Okay, so another property, this also you can remember. So let's revise what all properties we have seen. Very simple properties we have seen. Started from where? Determinant of a plus b will not be equal to determinant of a plus determinant of b, but determinant of a, b, c, d would be equal to determinant of a dot determinant of b dot determinant of c dot determinant of d, right? Then determinant of identity matrix will always be 1, no matter whatever the order is there. Then multiplying the determinant with the constant value means it will that constant value will be multiplied either in one of the rows or in one of the columns. Okay, not in all the rows or columns, only in one of the rows or column. But when it comes to matrix, if I multiply the matrix with the constant value, then that constant value will be multiplied in each element, not in some row or column. Understandable, right? And then we understood that how will I take out the constant sign out of a determinant value. Like here I took out the constant sign. How will I take it out? As k to the power n, where n is the order of matrix A. Matrix A is of order n cross n, so it will come out as k to the power n. Okay, you can find out the determinant of A, determinant of B, and determinant of C. Then what property we saw? We saw that the determinant of diagonal matrix, upper triangular matrix or lower triangular matrix is equals to the multiplication of their diagonal elements. Then we saw this problem. Here also we saw the one thing, that if I need to take out this 4, then it will come out as 4 to the power 3. Okay, then A transpose determinant is equals to determinant of A only. Then A to the power n, taking the determinant of A to the power n or taking the determinant of A and then doing the power n, both are the same thing. Understandable? Then we saw that if any of the rows or column are 0, then the whole determinant value will be 0. Then we saw that if two rows or two column, we will say the property with respect to row, but the same property will be applied in the columns as well. So if any two rows are interchanged, then the determinant value will be multiplied with -1. Okay, we are taking the example and then we are writing down the property. So this is the way to remember any property. I am not only talking about engineering mathematics. No matter whichever the subject you study, and if you feel like that, sir, I am not able to remember this particular thing, I am not able to recall this particular thing, then always remember the example. If you remember the example with respect to that particular property, then property will be there in your mind on its own. This is how I teach every subject, that we take the example first and then we go to the conclusion. Okay, so then only it will be there in your mind. Otherwise you will keep on remembering the properties and it will just become a history for you. But you are studying engineering, engineering will be understood with respect to an example, because there was one example first. From that example the property came out. It's not that property was there and then example came out. No, example was there, then property came out. No, so first we will learn the example and then we will see the property. Okay, here as well some property we are going to learn, but first you need to calculate the value. What will be the determinant value here? So you calculate these determinant value, determinant of A, determinant of B, determinant of C you calculate, determinant of D you calculate. Okay, and then we will see the conclusion. I will drink some water. It's been 30 minutes only, but again I need to drink water. So you calculate these determinant value, determinant of A, determinant of B, determinant of C, determinant of D. You calculate it on your own. I will drink some water and then I will come back. Okay, you do it. Yeah, welcome back. So did you try this one, guys? That you need to find out the determinant of A, determinant of B, determinant of C and determinant of D. If you did not try it on your own, then please try it. Okay, so what we will do, this is 1, I'm expanding with respect to row 1. So -1 plus 6, right? -1 plus 6 will be 5, then -2, and -2, 1 -4, this will also be 5, then -1, 3 -2, this will also be 5. So what is the answer you are getting? This is 5, this is -10 and this is 5. So you are getting the answer to be -10. Here also if you do the same thing, you will get the answer to be -10 only. You can expand it, you will get the answer to be -10. What will be the determinant B? This will be -10 only. We can check. 1 minus 1, this would be 9. Sorry, 1 minus 9, this would be 10. Then -2 here. 2 minus 6, this would be 8. Then -1 here. 6 minus 2, this will be 4. So 10 minus 16 minus 4. What we are doing? 6 minus 2, 4, minus 2, 8 and 10. Yes, -10 only. What I was thinking. This is -10 only. So similarly here also you will get the answer to be -10 only, and here also you will get the answer to be -10. Sir, how do you know it? Because here what we have done is that we have applied one operation. What operation we have applied? This is the operation we have applied. What we have done is that when we came from this matrix to, when we came from this determinant to this determinant, what we did? In row 2, I have added row 1. Your row 2 was replaced with the simple row 2 being added with row 1. So this was your row 2, 1, -1, -2. In that I added row 1, which is 1, 2 and -1. What you are getting? 2, 1 and -3. 2, 1 and -3. So in row 2 you have added row 1. This is the operation that you followed when you came from determinant of A to determinant of B. When I went from determinant of A to determinant of C, what operation did I apply? I applied the operation that in column 3, what we have done? In column 3, I subtracted column 1 and added column 2. What was your column 3? What was your column 3? Column 3 was -1, -2, 1. So from here I subtracted column 1 and added column 2. In column 3, what I did? I replaced the column 3 with subtracting column 1 and adding column 2. So what you will be getting? Minus 1, this will become 0, this will become minus 4, and next will become 2. So 0, minus 4 and 2. This is what I have written. So again I was getting the same answer. And in the last one, what I did, in second row again what I did was, I took the second row, then I added that twice of row 1 and subtracted that thrice of row 3. What I did here, this was my row 2, which was 1 minus 1 minus 2. Here I added that twice of row 1, twice of row 1. What is twice of row 1? That is 2, 4 and minus 2. And subtracted that thrice of row 3. What is thrice of row 3? 6, 9 and 3. I subtracted it. I subtracted it. So what is the answer you are getting? Here you will be getting minus 3. Here you will be getting minus 6. And here you will be getting minus 7. So this is how row 2 is replaced. So minus 3, minus 6, minus 7. So what is the again answer you are getting? Minus 10 only. So what do you understand from here? That in row and column you can do the linear transformation. Isn't it a linear transformation? What is the meaning of linear? Power 1. So here also power 1, here also power 1. Although here there is a constant factor, it doesn't matter. Power should be 1, no? Power is 1 here, power is 1 here, power is 1 here. Here also power 1, power 1, power 1. But along with that, take care of one thing, that in whichever the row or column I am performing the operation, let's just say I am performing the operation in R4. Then how will I perform the operation? R4 as it is. Now what I can do? I can do something with R1, with R2 and R3. Now alpha, beta, gamma value could be anything. Let's just say alpha value is 2. Beta value is minus 3. Beta value is minus 3. And gamma value is 7. But this remains as it is. R4 as it is. R4 is being replaced with R4 plus 2R1 minus 3R2 plus 7R3. Is that understandable to you or not? Okay. So this is another property. So what all properties we have seen? Although this is how I have written the property. What they are saying? That R1 could be replaced with R1 plus alpha R2 plus beta R3. R2 could be replaced with R2 plus A R1 plus B R3. R3 could be replaced with R3 plus M R1 plus N R2. Same goes with columns as well. Okay, but this remains as it is. C1 as it is. C2 comes as it is. C3 comes as it is. R1 comes as it is. R2 comes as it is. R3 comes as it is. So this is the sign of replacing. Okay, this is the sign of replacing. And this was the sign of interchanging, right? Do you remember the property of interchanging? That if two rows or column are being interchanged, then their determinant is multiplied with minus 1. Understandable? Now all these transformations are acceptable, but we will apply only one at a time. Like basically what I am saying is that I am replacing R1 with R1 plus 2R2 minus 3R4. So this operation I am going to apply in one step. In next step what I can do? That R2 is replaced with R2 plus 4R1 minus 3R2. Oh, sorry, not 3R2, because R2 can come somewhat like this. Like basically someone would say that, sir, can I do this thing? R1 is replaced with 3R2 minus 4R3. No. Basically, can I replace this row with, sir, double of this, then minus of triple of this? Can I do somewhat like this? No, you cannot do. If you are changing R1, then you have to use R1. I am replacing R1 with something, then I will have to use R1. Then plus something, minus something, plus something, whatever I want to do. If I am applying row operation, then everything happens with row. If I am applying column operation, everything happens with column, and one operation at a time only. Is that clear to you or not? Okay. We can apply multiple operation as well in one step. How we will apply, I will tell you the way. Don't worry. But the simple rule says that one operation at a time. If you want to avoid any mistake, then only apply one operation at a time. We will apply multiple operation as well, but once we build up the practice. Okay. Once we build up good enough practice, then we will be able to apply multiple operation. Okay. The rule is that whatever the rows or column are in use, they should not be used in the other operation. You are not able to understand what I am saying. So as of now, what you will understand that, sir, only one operation I will apply at a time. If I need to apply two operation in one line only, in one step, if I need to apply two operations, sir, how will I do it? That I will tell you, but with patience, because we will study ranks as well. So in rank as well, this kind of concept will come into action again and again. So there also I will tell you. So don't worry about it. You will build up enough practice of applying all these operations. So from this point, what you need to understand is that any kind of linear operation is acceptable. Only take care of one thing, that if R1 I am changing in R1, then R1 have to come into action without any factor here. R1 will come as it is, R2 will come as it is, R3 will come as it is. Sir, what if there is some factor? We will see that. We will see what happens. Or you can think on your own as well, that what will happen. Okay, so we will see that, don't worry. As of now, find the determinant of this particular matrix. So matrix A this was the matrix A. You need to find out the determinant now. So determinant of A you need to find out. So I can expand it. Without expansion, you need to find. You need to apply some property. So what do you think? What property you will apply here? What I sense is that in R2, if I replace R2 with R2 minus 2R1, won't I get R3? What I am saying, R2 should be replaced with R2 minus 2R1. This is our matrix. Okay. What I am doing? What operation I am applying? Why I am applying this operation, you will understand. Okay, have some patience. What I am doing is that R2 is replaced with R2 minus 2R1. So what you will be getting? So look, what is being replaced? R2 is being replaced. That means R1 will come as it is, R3 will come as it is. Who is getting replaced? R2 is getting replaced. No, so only R2 will change. So how R2 will change? In R2, whatever the values are there, in R2 what you will do? Twice of R1 you will subtract. What is twice of R1? So that will be 2, 4 and minus 2. You need to subtract it. So what you will be getting? 3 minus 2 will be 1. This will be minus 3 and this will be 4. So what you will be getting? 1 minus 3, 4. Why I was interested in this transformation? Because now I know that these two guys have become same. If these two guys have become same, what I can do now? Next transformation I can apply is that R3 is replaced with R3 minus R2. Now this is my new R2. Okay, this is my new R2 now. So next operation I am applying with R3 is replaced with R3 minus R2. Or what I could have done? I could have done is that R2 is replaced with R2 minus R3. Basically, this is my new R2 now. From this R2, I am subtracting R3. What I will get? 0, 0, 0, 0. Or what I can do? From this R3, I am subtracting R2. So one complete 0 row I will get. No. Are you able to understand this point? So I will apply one of the operation that R3 is being replaced with R3 minus R2. So same determinant I will be getting. Just the point is that this last row will become 0. And you know that if any of the row or column are 0, then the determinant value will be 0. So your answer is coming out to be 0. From here, one more conclusion you can make. What conclusion you can make? If any two rows or column are identical, if any two rows, in bracket I will write down, or two columns are identical, then determinant would be 0. Say yes or no. Why is that so? Because if they are identical, I can simply subtract them. One of the row will become 0, so answer will be 0 only. Okay, so this conclusion also you can make from here. Understandable? Right? So did you understand that how we are going to apply these operations? Now next question is that you need to perform this operation. R2 is being replaced with 2R2 minus 3R1 and you will get matrix B. So this is your matrix A. What will be your matrix B? In matrix B, what operation we are doing? That your second row is being replaced with twice of row 2 minus thrice of row 1. So what will be twice of row 2? That will be 8, 12. And what will be thrice of row 1? Thrice of row 1 will be 6 and 3. So what you will be getting? Subtracting them will give you 2 and 9. Okay. So what is your matrix B? Your matrix B would be, this is 2 1 and this is 2 9. Can you let me know what is determinant of A from here? What is determinant of A? 12 minus 4. What you are getting? 8. And what is determinant of B? 18 minus 2. What you are getting? 16. You are noticing one thing, that a determinant of A is coming twice of determinant of A. First, can you let me know, is this valid operation? No, sir. When you said that you need to apply operations, then you need to make sure that if I am changing R1, then R1 remains as it is. R2 remains as it is. R3 remains as it is. Column 1 remains as it is. But sir, here you are doing twice of this. Right? So it's not a valid operation. But let's think in a better manner that what we are doing. What I am supposed to do? I am supposed to do this operation, that R2 should be replaced with 2R2 minus 3R1. This is what I am supposed to do. Right? So let's find out the determinant directly. I am supposed to find out the determinant of A. Now in this one, this is my R1, this is my R2. So here first what I am doing, I am applying this operation, that my R2 is replaced with 2R2. If I do this thing, then what I will get? Let's just say I am getting some matrix C. Okay, you can write down determinant of C. So R2 is replaced with 2R2. R2 is replaced with 2R2. Who is changing? Only second row is changing. So it will become simply the twice. So 8, 12. Can you let me know what will be the relation between determinant of C and determinant of A? Think about it. Have we seen any property like that? R2 is replaced with 2R2. One of the row is being multiplied with the constant factor of 2. That means the whole determinant will become twice. From here, if you take 2 common, what you will be getting? From here, if I take 2 common, what I will be getting? 4, 6. So how will I take 2 common? This will be 4, this will be 6. And I told you, when it comes to determinant, common is taken from one of the row or from column. So if I take 2 common, this is what I will be getting. What is this? This is nothing but determinant of A. So 2 into determinant of A. So when I replaced R2 with 2R2, what really I got? I got twice of determinant of A. Now next operation what I am applying? In R2 only. Now this is my new R2. This is my new R2 now. This is my new R2. So in R2 what I am doing? I am subtracting 3R1. Now this is my new R2. So what I will get? 2, 1, no change. Thrice of R1. This is my new R1. Although R1 did not change, so new R1 or old R1 both are same. So thrice of R1. So thrice of 2 will be 6. So here you will be getting 2. And here you will be getting 9. So this is what I will be getting. Isn't it your determinant of B only? What is determinant of B? It is 2, 1, 2, 9. Isn't it the same? 2, 1, 2, 9. 2, 1, 2, 9. So isn't it the same? And now let me know, is this a valid operation? Yes. Yes, sir, it is a valid operation. So it will be equals to the determinant of C only, or you can say it will be equals to determinant of twice of determinant of A. So from here what you are getting? This is the relation you are getting. Did you understand this point? So here when I said that this thing that R1 should come as it is, what if I would have said that R1 is coming as alpha R1 plus beta R2 plus gamma R3, then the determinant value will be multiplied with the factor of alpha. Previously my determinant was A, then I applied this operation, new determinant I will be getting determinant B, that will be twice of determinant of A. That's it. This is a valid operation if you are multiplying one of the row with the factor of alpha. R1 is being replaced with alpha R1, then your determinant will also be becoming twice. These guys does not matter. Alpha, beta, these A, B, they do not matter. But if R1, a particular row which is being replaced, that is being multiplied with a constant factor, then that constant factor will come out. Rest all are being subtracted or added, I don't care. Is that clear to you? That how we are applying the operation? And if we are applying the operation multiplying with the constant value, then what will happen with the determinant? Is that clear to you as well? So first we solved by the simple method that this is what we are supposed to do and we got the answer. But what is the conclusion we are making from here? That I could have broken down this expression or this transformation into two steps. That first I am doing the twice of rho, and then I am subtracting thrice of R1. So when I am doing twice of rho, then I am getting twice of determinant. Then thrice of R1 I need to subtract, so nothing will change, right? Because this is your new row, this new row remains as it is. Thrice of R1 I am subtracting, so nothing is changing here, because that is the acceptable linear transformation. So here determinant of B and determinant of C will be same, which is equal to twice of A. Understandable? Solve this question on your own. Have some patience, solve it on your own. I expect the correct answer from everyone's side. What is given? Matrix A is of order 3 cross 3 with the determinant of A equals to -3. Understandable? New matrix is defined. What is given? This is -3, order is 3 cross 3. B is given as 2A. C is given as A cube. Now what we are doing? From A to D I am going with R2 being replaced with R3. So can you let me know what will be the relation between determinant of D and determinant of A? One of the two rows are being interchanged with each other. So determinant of D would be equals to determinant of -A. We have seen this property, no? Rows being interchanged. Where was the property? Yeah, rows being interchanged, then determinant becomes negative, right? So what was written? If any two rows or two columns of a determinant are interchanged, then the value of determinant is multiplied with -1. So when you go from A to D, this is what you are doing. So what will be the determinant of D? That would be minus of 3, minus of -3. That will become 3 only. So determinant of D will be 3. When you are going from D to C, D to E, what is happening? C1 is being replaced with C2. C1 is being replaced with C2. That means again two columns are being interchanged with each other. What does that mean? Determinant of E would be equals to minus of determinant of D. What that would be equals to? Determinant of D is 3. So this will become -3. Did you understand this point? From here what we have got, determinant of D is coming out to be 3 and determinant of E is coming out to be -3. Till this point everything is fine or not? If you are changing two rows or two columns, if you are interchanging two rows or two columns, then their determinant will be multiplied with -1. Understandable? Now from E to F, how you are going? R3 plus 2R1. Is this acceptable operation or not? Yes sir, surely it is acceptable, and R3 is coming as it is, sir. No change, sir. R3 is coming as it is, no change. So from here what you can understand, the determinant of E is nothing but a determinant of F. That would be equals to -3. So from here determinant of F we are getting as -3 only. Now from F to G you are going 3C1 minus 2C2. So sir, this operation is acceptable. But sir, when I am going from C1 to 3C1, then there is a problem. My determinant will be multiplied with the factor of 3. So determinant of G would be, when I am going from C1 to 3C1, so determinant of G would be thrice of determinant of F. So thrice of determinant of F, that would be -9. So determinant of G would be -9. Did you understand why it will be -9? Same example that we saw here, that R2 is first replaced with 2R2. So here what will happen? C1 will be first replaced with 3C1. Just as you replace with 3C1, the determinant became thrice. Just as the determinant became thrice, after that you can apply this operation, does not matter. Okay, so determinant of G would be -9. So determinant of G we have, E we have, F we have, determinant of D we have, determinant of C I need to find out. So what will be the determinant of C? Can you let me know? Determinant of C would be what? What is C is given as? C is A cube. So C is nothing but A cube. I told you one thing, this cube can come out. Determinant of A to the power n is nothing but determinant of A to the power n, right? So determinant of A cube, determinant of A is -3 cube, which will be -27. So determinant of C is coming out to be -27, right? Determinant of C, A cube, determinant of A, this cube is simply coming out, determinant of A is -3 cube, 7. Now what about B equals to 2A? So what you need to find out? Determinant of B. What is B? B is nothing but 2A. Let me know how this 2 will come out. 2 will come out with being power n. What is the order? 3 cross 3. So power 3. Do you remember this thing? K into A. Determinant of K into A. So that will come out as K to the power n. Here 3 cross 3. So it came out as 4 to the power 3. 4 to the power 3. 4 to the power 3. Right? And I also wrote it down here. Yes. Determinant of K. So if K comes out, then you need to know what is the order of A. That is n cross n. So K to the power n. And sir, why this happens? Completely we proved here. Right? Minus 2A, then you know that minus 2, minus 2, minus 2, thrice it will come out. So minus 2 to the power 3. So here as well, what is happening? Yeah, 2 to the power 3, determinant of A. So this will become minus 24. So determinant of B would be minus 24. Okay, so then you need to add all of them, then you will get the answer. So 3 it is gone. 39 plus 24 will be 63, right? Or 53. 53 minus 53 is the answer, I guess. This is the answer I'll be getting. Determinant of D is simply the negative, then determinant of E, then determinant of F, both are same. E, F is becoming minus 3, minus 3, minus 9. So let me explain it again. Started with the B equals to 2A. So determinant of B would be 2 to the power 3 of this. 2 to the power 3 is nothing but 8. 8 into minus 3 would be minus 24. What about C? So it would be simply the cube of it. Then minus 3 cube. That would be minus 27. Understandable? Very simple thing. What about the determinant of D? Determinant of D. Where is determinant of D? Determinant of D is simply the negative of determinant of A, and determinant of E is simply the negative of determinant of D. Okay, so determinant of D is 3, determinant of E is minus 3. E to F, acceptable operation, minus 3. F to G, thrice it will become, so yeah, 3 into minus 3 into 3, so it will become minus 9. Okay, so all these are correct values. 3 and 3 gone, minus 3 and minus 9, that would become minus 12. Minus 12 plus minus 27, that would become minus 39. And minus 39 plus 24, what that would become? 40, 50, 60. Yeah, 39, 24, 63. Okay, this will become 63. Understandable? So answer is minus 63. Let's go to another property is there, one more property is there. So with respect to determinant, let's just say this is, with respect to matrix, if this is matrix A, if I need to break it down, how will I break it down? I can break it down into two matrices, right? Matrix A plus matrix B. Okay, since this is matrix A, so I will call it matrix B plus matrix C. So A and J, A here and J here, A plus J. B, K, so B here and K here. C, L, C here, L here. D, M, D plus M. E plus N. F plus O. G plus P. H plus Q. And I plus R. If you add both of them, this is what you will be getting. So this is how I break them out, right? In case of determinant, what really happens? It goes row wise. Okay. Basically, how will I break it down? I will break it down somewhat like this. That I can break it down into two determinants. So forget about J, K, L. If I only need to write down A, B, C, then this is, remains as it is, D, E, F, G, H, I. So A was added with J, so J. B was added with K, K. C was added with L, L. Then D, E, F, G, H, I. Did you understand what I did here? Basically, if I needed to break down this one, how will I break it down? So let's try breaking this down. Okay, let's try breaking this down when it comes to determinant. So how will I break it down when it comes to determinant? So let me add a page and then we will break it down. You can do it row wise as well, or whatever the operation that we are doing with respect to row, the same operation are applicable for column as well. Always remember. Okay. So how I am breaking it down? I am breaking it down into, first I am breaking it down into two steps. So how it will be broken down? That, sir, everything remains as it is. I am removing JKL from here. If you are removing JKL from here, then you have to make another matrix, sorry, another determinant where you are having JKL. Is that understandable to you? So basically only in one row this operation is happening. Plus operation is happening only in one row. Is that clear to you? Only in one row. A plus J, so A and J are separated. B and K are separated, C and K are separated. But rest of the rows remain same. Is that clear to you? So this operation, this is perfectly fine. Whatever that we have done, that is perfectly fine. Now, sir, I want to change them as well. Like this plus M plus N plus O. So another row you need to do. Like how will you break this one down now? This could be broken down into two determinants. How will you break this? How will you break this one? That I am only breaking this one. That this is my determinant. This is my determinant. I am breaking it into two determinants. Okay. So this was the determinant, right? A, B, C, D plus M. This was the determinant as it is. I have written here. How will I break it into two determinants? Same way. Here what I have done, I broke it down into two determinants, right? I broke this one down into two determinants. How will I break this one into two determinants? M and O I need to take separate. So M and O I need to take them separate. Same determinant, and first this one is gone. Okay, so this is how they are broken into two. This one is broken into two. You can break this one as well. Are you able to understand what I am saying? Are you able to understand this property? Have some patience, like look at it carefully, then you will be able to understand. A plus J, B plus K, C plus L. Only row wise we can go. That's our A, B, C, D plus M, E plus N, F plus O, G plus P, H plus Q, I plus R. So A, B, C if we have done, then plus this we can do. J, K, L, and rest all remains as it is. So both, if we add both of them, then we will get this determinant only. Now someone would say that, sir, I need to break these two guys as well. Then this is how I will be breaking it. That now this determinant I need to break into two parts. So ABC as it is, this row as it is. Now this row I am breaking into two parts. So DEF, M and O. DEF, M and O. Someone would say that, sir, I need to break this one into two parts. So that also you can do. Right? How will you break into two parts? Let us say I am keeping this as it is, and this I am breaking into two parts. So JKL as it is, D plus M, E plus N, F plus O as it is, then GHI plus PQR, GHI, PQR, rest these two rows remains as it is. So this is how you can break this one into two parts as well. Is that clear to you? I hope it is clear. Okay, so this one could also be broken into two parts. So what I would do is that I will remove this particular scenario, because you will think that both are equivalent, but I am breaking only one determinant. Then this also should be broken. So from these two determinants we will get four more determinants. I hope that is clear to you. Okay, so this is how we are breaking it, and both are equivalent to each other. Is that clear? Then this could be broken into two parts. This could also be broken into two parts. How this could be broken into two parts? Roughly I am writing down. So I am assuming that first row as it is, third row as it is, only I am doing the operation in second row. So D, E, F and M, N, O. First and third remains as it is. What about this one? Here I am assuming that first and second remains as it is, and I am breaking the third one. G, H, I, P, Q, R, P, Q, R. These two remains as it is. Okay, these two remains as it is. Here, these two remains as it is. Understandable? Then again they can be broken into two parts. Again they can be broken. In that manner, it may keep on going. Although you will apply this property rarely, but still, if it is there, if it is need to be taught, then I am teaching it. Okay, so this was the last property. Now we will solve some numericals. That how will you find out the determinant of this kind of matrix if it is given? Okay, first question. Okay, this is the second question. This is the third question. Then area of triangle, fourth question, and then fifth question. Okay, so let's do it in the next lecture. In the next lecture as well, again we are going to study basics of a matrix and determinants only. Okay, what we are going to study? Basics of a matrix and determinant. That will be our part 3. So it's been already 3 hours of video. So let's end it here. Then we will see these determinants, and then we will see the concept of adjoint, and from there concept of inverse of a matrix will come into action. Okay, so let's see it in the next video. Okay, fine. So let's see in the next video. Again we are continuing the lecture only. Basics of matrix and determinants we are studying. It will be continued in the next lecture as well. Yeah. I hope this property is understandable to you. It was a bit odd property. I was comparing it with the matrices. In matrices directly we can write it down, but in determinant one of the row could be broken into two parts at a time. So one of the row could be broken into two parts, then again two parts, then again two parts. In that manner it can keep on going. Understandable? So let's see these kind of numericals. Okay, so let's do it in the next lecture. Thank you.